하나, 둘, 셋. 아, A, A, B, A, 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 A. 영어 채널.
안녕하십니까. 영어 채널입니다. 지금 목소리 들리시는 건 영어 채널입니다. Hello, hello, my name is, yeah. Okay, come on. Hello. 안녕하십니까. Hello, hello, hello. A, B, C, D, E, F, G, H, G, A, B, C, D. I got it. Hello.
New roads of delivery. Unico Logistics. Unico Logistics, as a global comprehensive logistics company of possessing 43 overseas LLCs and branches with powerful global network, provides ocean freight, railroad transportation, heavy logistics projects, and air freight service, and also provides warehouses, customs clearance, delivery, and intercontinental truck transportation services. Unico, as a global player, is transporting freights from all over the world to the optimum routes depending on the size and type of the cargo. Freights of various industries such as construction, engineering, electronics, chemicals, and automobiles are shipped to the customer's designated destinations through our worldwide network in the most reliable and fastest way. Unico is in the transport of project freights anywhere in the world. With our infrastructures in global networks, and with our live controlling system and experiences, we've been able to succeed bulk shipment projects for fuel, gas, chemical, and power plants of global construction companies. Which means our project freight transportation capability is provided to meet the client's needs. That's why Unico can be found at any heavy engineering project sites. Unico's know-how and network continues to develop in the air. By affiliating with all the major airlines in the world, we provide the best service through years of shipping experience. In addition, warehouses and trucking services are prepared at any time and anywhere in our overseas locations around the world for the customer's convenience and needs. Also, as we possess our own dry bulk carriers, we've made shipments of imported raw materials used in domestic and overseas power plants and steelworks, such as coal and grain, which we achieved an increase of 30% or more in cargo fulfillment rate every year. With these achievements, we will continue to serve as an industrial carrier by increasing our fleet. Our efforts for the future will continue until Unico's logistics and shipping are established in major cities around the world and become a truly global player. Our voyage will continue. Unico Logistics.
Tschudi Shipping Company, a privately owned Norwegian company. The Tschudi Group is a shipping and logistics group focusing on east-west trade and projects involving the Baltic states, Russia, and the CIS countries, including the northern regions of Russia and Norway. Since the early 90s, the group has had an interest in the northern regions, based on a belief that this will be an extremely positive development for the region compared with other areas of the world. In 2006, Tschudi became substantial landowners in Kirkenes, the Norwegian border town with Russia. The group's 1 million square meters shoreline in Kirkenes will be developed into an integrated port for industry and logistics. The Kirkenes Industrial Logistics Area, HILA, to serve the future needs of the oil, gas, and mining industries in the region. Due to their interest in the high north and Arctic region, Tschudi Shipping Company was among the pioneers to initiate the first non-Russian commercial shipment through the Northern Sea route to China. The bulk carrier, MV Nordic Barents, successfully transported a cargo of iron ore from the Sydvaranger mine in Kirkenes to China in 2010. Tschudi Shipping Company, TSC, was founded in 1883. and has accumulated many years of experience working on projects in Russia, the Baltic states, and North Norway. Tschudi Arctic Transit, TAT, is a wholly owned subsidiary of TSC, founded in 1996, with the aim to develop transport solutions for cargo to and from Russia, and to serve the oil and gas industry with transport throughout the Barents region. The level of activity within the oil and gas sector is set to increase in the near future, and this will require an increase in the transport systems offered. Yet another exciting opportunity is the Northern Sea Route, providing sailings through the Northeast Passage during the summer season. One of the services provided by TAT in this sector is the reloading of oil products in the region. And the company has acquired invaluable experience of such operations. One example of such an operation is when the Vladimir Tikhanov, Suezmax class with a total of 162,000 deadweight tons, sails into the North Cape waters in the autumn of 2011 to load 120,000 tons of gas condensate. As the ship approaches the harbour boundary, she is boarded by a pilot and escorted by tugboats to a secure and precise position at the anchorage in the Sandnesfjord, nearby Honningsvåg. An authorised loading-unloading master now takes charge of the operation, anchoring the huge vessel and making the ship ready, putting out large fenders. 2 tankers, Panamax class and with 75,000 DWT each, have already been loaded with the gas condensate to be reloaded. The 2 tankers arrive in the Sandnesfjord, accompanied by a pilot, and are manoeuvred safely by tugboats to a secure shipside position. Once the tankers are ready, a comprehensive security procedure has to be carried out, involving all the personnel and crew who will be working on the operation. A number of checklists have to be reviewed before the operation can start. The first task is to lay oil booms around the ship and connect hoses for transfer between the ships. During the entire operation, 2 tugboats and 1 standby boat are close by and at the ready. The loading-unloading operation can now start, and the transfer of the gas condensate will take approximately 18 hours per tanker and will be closely monitored throughout the operation. Once the operation is completed, the couplings are removed and the empty tankers haul up their anchors and sail out of the Sandnesfjord. Now the tankers have left the area, the oil booms and fenders have to be removed, and the Vladimir Tikhanov can sail out of the Sandnesfjord with its pilot on board. The operation is successful, and there are no unnecessary incidents. The ship is now ready to start its voyage through the Northern Sea Route, carrying its cargo to Thailand as the largest ship ever to make this sailing. Tschudi Arctic Transit aims to further develop its transport solutions and the potential already present in this region. Keeping in mind the increased level of activity and the valuable experience we have gained, we are confident that our transport solutions will be a very attractive part of the developments to come into the High North.
Northeast Asia, leader of the global economy. And at the center, Busan Port. Global hub, Busan Port. Since its opening, Busan Port has seen continuous growth as the main port of Korea. Through its handling of both Korea's imports and exports, and its transshipment of freight from all over the world, Busan Port has helped lead Korea's economic development. Through the accuracy, efficiency, and optimal productivity of marine transportation services at specialized port facilities in Busan Newport, Northport, Gamcheon Port, and Dadepo Port. Busan Port handled a total of 20 million TEU of container shipments in 2017. Busan Port is now aiming to become a global logistics hub port with a new goal of 30 million TEU in 2030. Located on the main shipping route between Europe and North America, Busan Port is busy establishing a global network to connect over 600 ports in more than 150 countries around the world. Here, with the latest facilities and excellent manpower, Busan Port provides stable marine transportation and port logistics services to customers 24 hours a day, 365 days a year. Busan Port is effectively managed, dealing preemptively with changes to the maritime environment and shipping alliances reshuffling, and preparation to receive ultra-large container vessels. Busan Newport is a central transshipment port, attracting the vessels of global, mega-scale shipping companies. For this purpose, Newport boasts outstanding port infrastructure, a wide port district park, and an unbeatable connected transportation network. Meanwhile, Busan Northport has an important role as a hub port for intra-Asia shipping companies. Designated as a free trade zone, the Newport District Park Complex is the large-scale business complex that offers high-value logistical services alongside various incentives and tax exemption benefits. Busan Port will expand its optimal infrastructure and port facilities to enable super-scale 30,000 TEU vessels to dock, also helping create high-quality jobs and reinvigorate the local economy. Busan Port is currently redeveloping the Northport's rundown facilities into a center of international maritime tourism and destination demonstrating harmony between people, business, culture, and art. The complex aims to become a focal point for the new maritime economy, bringing in over 10 million visitors a year to its eco-friendly waterfront, marina, broadcasting studio, exhibition and convention center, and other attractions. This new maritime capital for Northeast Asia is expected to create 120,000 additional jobs and an economic value of 32 trillion Korean won. Busan Port Authority was established in 2004 as Korea's first port authority, with the mission of cultivating Busan Port into a top 2 global transshipment hub. In line with the 4th Industrial Revolution, bringing limitless innovation and challenges, we have formed a smart port with optimized cargo handling systems implementing clean, green, and eco-friendly policies. Through safety measure and welfare systems for port workers, we have formed a people-oriented port environment. To become a port that the Korean people can be proud of, Busan Port Authority makes the utmost of efforts to create an optimal business environment. Through the improvement of port-related employee welfare and aid, implementing social values as a public corporation, and leading the global market of maritime transportation and port logistics. Busan Port will become a hub for maritime business, tourism, and port services, and be the center of new maritime economy. From the gateway to Asia to the center port of the world, Global Hub, Busan Port.
Now we are ready to start the 9th International Arctic Shipping Seminar. Well, in the morning we had an academic session and discussed a lot of issues, but I'd like to ask for your understanding once again that we had some technical difficulties and disturbance. Again, opening the 9th International Arctic Shipping Seminar, we will have an opening ceremony first. We have an opening remark by Director Chun Seok Kim, Shipping and Logistics Bureau, the Ministry of Oceans and Fisheries. Good afternoon. I'm Chun Seok Kim, head of the Shipping and Logistics Bureau under the Ministry of Oceans and Fisheries. Despite difficult conditions around the world due to the COVID-19 pandemic, it is very meaningful to have the 9th International Arctic Shipping Seminar to discuss the current status of the Northern Sea Route and future prospects. The Northern Sea Route is the shortest passage from Asia to Europe, which is an advantage, and backed by vast amounts of natural resources buried in the nearby region. Russia, as well as many nations in Europe and Asia, are showing growing interest and making efforts to pioneer the NSR. Russia, the leader in NSR development, has established early this year the Northern Sea Route Infrastructure Development Plan until 2035, and Russia expects the cargo volume via the NSR, which was 31.5 million tons last year, will reach 160 million tons by 2035. In addition, as part of the NSR Infrastructure Development Plan, at both ends of NSR, Kamchatka and Murmansk, LNG terminals with storage and transshipment functions are under construction, and they are planned to start operation in 2023. And construction of state-of-the-art ice-class vessels capable of transporting LNG without icebreaker support has been continuously increasing. These development policies also present good opportunities to Korean companies. DSME has secured this year orders for 6 LNG carriers, and Samsung Heavy Industries, since last year, has been participating in technical cooperation with its Zvezda shipyard in Russia for LNG carrier construction. In addition, in line with growing environment-friendly policies centered on Asia, LNG demand is increasing. In this context, the LNG transshipment terminal to be operated in Kamchatka is expected to present many opportunities to local shipping and logistics companies. However, despite these possibilities and prospects, there are negative viewpoints as well on the NSR. For operations between Europe and Asia, the NSR does not have any stopover in the middle, and therefore economic viability is deemed not good enough. And some global corporations and large European shipping companies, including MSC, have clearly stated that they will not use the NSR on the grounds of environmental concerns. As such, the NSR has mixed assessments and prospects. Against this backdrop, it is very meaningful to have this seminar where participants from industries, academia, and research institutes will evaluate NSR development progress and discuss future prospects and countermeasures. I ask all participants to give policy suggestions without restrict constraint, and we will fully take the discussion at the seminar into account when establishing shipping and logistics policies, including the NSR. In closing, I thank all members from organizing bodies for their effort in preparing the seminar, and I wish everyone good health and happiness. Thank you. Once again, there was a opening remark from Jun Seok Kim from the Ministry of Oceans and Fisheries. Now we will have a congratulatory remark by Gi Chan Nam, President of Busan Port Authority. Good afternoon, everyone. I'm Gi Chan Nam, President of the Busan Port Authority. Despite difficult conditions due to ongoing COVID-19 pandemic, I congratulate you on the grand opening of the 19th International Arctic Shipping Seminar, and I'd like to thank members of the Institute of Arctic Logistics at Yonsei University for their effort. Interests of each nation surrounding the Arctic are intensifying. At this juncture, it is very meaningful to have this seminar where we will look into trends of infrastructure and development in the Arctic and discuss future directions. Starting from 2024, the Northern Sea Route will have active commercial operations in the region, and I believe it will provide the Port of Busan with an opportunity to generate new demands. I sincerely hope that today's seminar will be a fruitful event contributing to policy and strategy development. And I hope it serves as a chance to further promote continued interest and research on the Northern Sea Route. Thank you very much. Well, once again, it was a congratulatory remark from Gi Chan Nam from BPA. Okay, we have one last program of the opening ceremony. I'd like to ask all the participants who are gathered here, including speakers, to come up on the stage. And we have also other speakers who are connected online via Zoom. So the seminar is held both at online and offline. So we will have a moment to take a commemorative photo session. So I'd like to once again ask all the participants to come up onto the stage. Okay, with this, we will wrap up the opening ceremony. So starting from 1:30 Korea time, we will have a keynote presentation by Mr. Felix Tudi, chairman of Tudi Shipping Company Norway. Once again, we will be back at 1:30. Thank you very much.
New roads of delivery. Unico Logistics. Unico Logistics, as a global comprehensive logistics company of possessing 43 overseas LLCs and branches with powerful global network, provides ocean freight, railroad transportation, heavy logistics projects, and air freight service, and also provides warehouses, customs clearance, delivery, and intercontinental truck transportation services. Unico, as a global player, is transporting freights from all over the world to the optimum routes depending on the size and type of the cargo. Freights of various industries such as construction, engineering, electronics, chemicals, and automobiles are shipped to the customer's designated destinations through our worldwide network in the most reliable and fastest way. Unico is in the transport of project freights anywhere in the world. With our infrastructures in global networks, and with our live controlling system and experiences, we've been able to succeed bulk shipment projects for fuel, gas, chemical, and power plants of global construction companies. Which means our project freight transportation capability is provided to meet the client's needs. That's why Unico can be found at any heavy engineering project sites. Unico's know-how and network continues to develop in the air. By affiliating with all the major airlines in the world, we provide the best service through years of shipping experience. In addition, warehouses and trucking services are prepared at any time and anywhere in our overseas locations around the world for the customer's convenience and needs. Also, as we possess our own dry bulk carriers, we've made shipments of imported raw materials used in domestic and overseas power plants and steelworks, such as coal and grain, which we achieved an increase of 30% or more in cargo fulfillment rate every year. With these achievements, we will continue to serve as an industrial carrier by increasing our fleet. Our efforts for the future will continue until Unico's logistics and shipping are established in major cities around the world and become a truly global player. Our voyage will continue. Unico Logistics.
Northeast Asia, leader of the global economy. And at the center, Busan Port. Global hub, Busan Port. Since its opening, Busan Port has seen continuous growth as the main port of Korea. Through its handling of both Korea's imports and exports, and its transshipment of freight from all over the world, Busan Port has helped lead Korea's economic development. Through the accuracy, efficiency, and optimal productivity of marine transportation services at specialized port facilities in Busan New Port, North Port, Gamcheon Port, and Dadepo Port. Busan Port handled a total of 20 million TEU of container shipments in 2017. Busan Port is now aiming to become a global logistics hub port with a new goal of 30 million TEU in 2030. Located on the main shipping route between Europe and North America, Busan Port is busy establishing a global network to connect over 600 ports in more than 150 countries around the world. Here, with the latest facilities and excellent manpower, Busan Port provides stable marine transportation and port logistics services to customers 24 hours a day, 365 days a year. Busan Port is effectively managed, dealing preemptively with changes to the maritime environment and shipping alliances reshuffling, and preparation to receive ultra-large container vessels. Busan New Port is a central transshipment port, attracting the vessels of global, mega-scale shipping companies. For this purpose, Newport boasts outstanding port infrastructure, a wide port district park, and an unbeatable connected transportation network. Meanwhile, Busan North Port has an important role as a hub port for intra-Asia shipping companies. Designated as a free trade zone, The Newport Distripark Complex is the large-scale business complex that offers high-value logistical services alongside various incentives and tax exemption benefits. Busan Port will expand its optimal infrastructure and port facilities to enable superscale 30,000 TEU vessels to dock, also helping create high-quality jobs and reinvigorate the local economy. Busan Port is currently redeveloping the North Port's rundown facilities into a center of international maritime tourism and destination demonstrating harmony between people, business, culture, and art. The complex aims to become a focal point for the new maritime economy, bringing in over 10 million visitors a year to its eco-friendly waterfront, marina, broadcasting studio, exhibition and convention center, and other attractions. This new maritime capital for Northeast Asia is expected to create 120,000 additional jobs and an economic value of 32 trillion Korean won. Busan Port Authority was established in 2004 as Korea's first port authority, with the mission of cultivating Busan Port into a top 2 global transshipment hub. In line with the 4th Industrial Revolution, bringing limitless innovation and challenges, we have formed a smart port with optimized cargo handling systems implementing clean, green, and eco-friendly policies. Through safety measure and welfare systems for port workers, we have formed a people-oriented port environment. To become a port that the Korean people can be proud of, Busan Port Authority makes the utmost of efforts to create an optimal business environment through the improvement of port-related employee welfare and aid, implementing social values as a public corporation, and leading the global market of maritime transportation and port logistics. Busan Port will become a hub for maritime business, tourism, and port services, and be the center of new maritime economy. From the gateway to Asia to the center port of the world, Global Hub, Busan Port.
Tschudi Shipping Company, a privately owned Norwegian company. The Tschudi Group is a shipping and logistics group focusing on east-west trade and projects involving the Baltic states, Russia, and the CIS countries, including the northern regions of Russia and Norway. Since the early 90s, the group has had an interest in the northern regions, based on a belief that this will be an extremely positive development for the region compared with other areas of the world. In 2006, Tschudi became substantial landowners in Kirkenes, the Norwegian border town with Russia. The group's 1 million square meters shoreline in Kirkenes will be developed into an integrated port for industry and logistics. The Kirkenes Industrial Logistics Area, HILA, to serve the future needs of the oil, gas, and mining industries in the region. Due to their interest in the high north and Arctic region, Tschudi Shipping Company was among the pioneers to initiate the first non-Russian commercial shipment through the Northern Sea route to China. The bulk carrier, MV Nordic Barents, successfully transported a cargo of iron ore from the Sydvaranger mine in Kirkenes to China in 2010. Tschudi Shipping Company, TSC, was founded in 1883 and has accumulated many years of experience working on projects in Russia, the Baltic states, and North Norway. Tschudi Arctic Transit, TAT, is a wholly owned subsidiary of TSC, founded in 1996, with the aim to develop transport solutions for cargo to and from Russia, and to serve the oil and gas industry with transport throughout the Barents region. The level of activity within the oil and gas sector is set to increase in the near future, and this will require an increase in the transport systems offered. Yet another exciting opportunity is the Northern Sea Route, providing sailings through the Northeast Passage during the summer season. One of the services provided by TAT in this sector is the reloading of oil products in the region. And the company has acquired invaluable experience of such operations. One example of such an operation is when the Vladimir Tikhanov, Suezmax class with a total of 162,000 deadweight tons, sails into the North Cape waters in the autumn of 2011 to load 120,000 tons of gas condensate. As the ship approaches the harbour boundary, she is boarded by a pilot and escorted by tugboats to a secure and precise position at the anchorage in the Sandnesfjord, nearby Honningsvåg. An authorised loading-unloading master now takes charge of the operation, anchoring the huge vessel and making the ship ready, putting out large fenders. 2 tankers, Panamax class and with 75,000 DWT each, have already been loaded with the gas condensate to be reloaded. The 2 tankers arrive in the Sandnesfjord, accompanied by a pilot, and are manoeuvred safely by tugboats to a secure shipside position. Once the tankers are ready, a comprehensive security procedure has to be carried out, involving all the personnel and crew who will be working on the operation. A number of checklists have to be reviewed before the operation can start. The first task is to lay oil booms around the ship and connect hoses for transfer between the ships. During the entire operation, 2 tugboats and 1 standby boat are close by and at the ready. The loading-unloading operation can now start, and the transfer of the gas condensate will take approximately 18 hours per tanker and will be closely monitored throughout the operation. Once the operation is completed, the couplings are removed and the empty tankers haul up their anchors and sail out of the Sandnesfjord. Now the tankers have left the area, the oil booms and fenders have to be removed, and the Vladimir Tikhanov can sail out of the Sandnesfjord with its pilot on board. The operation is successful, and there are no unnecessary incidents. The ship is now ready to start its voyage through the Northern Sea Route, carrying its cargo to Thailand as the largest ship ever to make this sailing. Tachudi Arctic Transit aims to further develop its transport solutions and the potential already present in this region. Keeping in mind the increased level of activity and the valuable experience we have gained, we are confident that our transport solutions will be a very attractive part of the developments to come into the High North.
Tachudi Shipping Company first conducted international transit via NSR of steel back in 2010, and The company has provided ship-to-ship transshipment service in the Arctic Sea. That is why we've invited the president and CEO and chairman of Chudy Shipping for the keynote speech. And the title is 10 Years of Accelerating Arctic Shipping. What will
First of all, thank you to Professor Hong and his team at the Institute of Arctic Logistics at Yongsan University to let me present here today. My topic will be 10 years of accelerating Arctic shipping. What will it take for it to continue? The Chudy Group is a shipping, logistics, and ocean industry solutions provider with particular focus on east-west cargo flows involving the Baltic, Russia, and the CIS countries, as well as logistics and infrastructure in the Arctic. To deliver, we are drawing on or combining the competences of the whole Chudy Group. The Chudy Group in the Arctic reflects our main business areas: the ocean industries with ship-to-ship transshipment of oil and LNG, oil spill prevention and support for the fish farming industry, cross-border logistics in the region, development of natural resources, iron ore and aggregates, and port and infrastructure development, mostly in Kirkenes on the border to Russia. The Kola Peninsula and northern Norway form an all-year ice-free wedge into the Arctic, a natural logistics platform for the region. We chose Kirkenes as our main base in the north due to this ice-free port and proximity to Russia. Knowledge of a passage to China via the north was known from the 16th century and possibly earlier, but systematic commercial use was only contemplated from the 1870s onwards. Two of my heroes, Captain Joseph Wiggins and Mr. Jonas Lied, took initiatives to develop the Kara Sea route with Russian partners in stages between 1874 and 1918. The Siberian Steamship Company, run by the Norwegian Jonas Lied, operated from 1912 until the Russian Revolution. In September 2010, Chudy Shipping Company arranged the shipment of iron ore concentrate via the NSR from the Sydvaranger iron ore mine in Kirkenes to the port of Lianyungang in China. For the first time, a non-Russian vessel carried a non-Russian cargo between two non-Russian ports, proving to the world that the NSR is an international trade route open to all. The Chudy Group is now working to reopen the Sydvaranger mine and start shipping through the NSR again. The Northern Sea route turns a freight disadvantage into an advantage. There are substantial savings of time, fuel, and reduced pollution to air compared with the Suez or Cape passage. The most important takeaway from the past 10 years of NSR transits is the wide range of vessels that have successfully used it, proving that it is a viable trade route for many different cargoes and uses. Having been a part of the NSR fan club for more than 10 years, we have been thinking a lot about how to promote its future use. We realized early that destinational shipping with specialized vessels would be the main activity to start with. These very expensive vessels should be used on the shortest possible distance where their capabilities were really required. That meant that there would be a need for transshipment points. That would be our contribution. The first mover with regard to organized destinational shipping was Norilsk Nickel, with vessels built already in the mid-2000s with a Finnish Aker Arctic icebreaking design, mainly using Murmansk as transshipment hub for cargoes to and from Tudinka on the Yenisei River. Thereafter came transshipment of oil in specialized ice-breaking tankers. The shallow coast of the Arctic requires offshore loading facilities. Over the past 2 years, Chudy Arctic Transit, on behalf of Yamal LNG, has organized LNG ship-to-ship operations totaling more than 20 million cubic meters from the ice-breaking Arc 7 double-acting LNG carriers to conventional vessels. The operation proved that large-scale transshipment was possible during the Arctic winter with a well-organized operation in sheltered waters. It showed how Arctic infrastructure, such as these $350 million vessels built at Daewoo, can be utilized in the most efficient way by transshipping at both ends of the NSR. Yamal LNG, until now the most important boost to the new NSR, will from 2023 use permanently installed floating storage units on the eastern and the western side, and has now tested out a new temporary site at the Kildin Island outside Murmansk. In the future, we believe there will be more land-based and or floating terminals serving other Arctic resource developments, including minerals, metals, and coal, in addition to oil and natural gas. Also for general cargo and other supplies, the Yamal project has been crucial. One example is the supply of rock from Kirkenes to Sabetha. Yamal LNG and other Arctic developments require enormous logistical efforts to move equipment and plant into the areas of construction and later to serve the ongoing operations. As an example, today Arkhangelsk port is absolutely full with cargo for the new development, Arctic LNG 2 at Gudang. Kirkenes's advantage as a supplier of large volumes of crushed rock is that it can be transported at lower cost with large vessels. This illustrates how infrastructure across the borders can serve the neighbors' needs. These graphs from Center for High North Logistics show how the total use of the NSR has accelerated over the past 5 years, both in terms of numbers of vessels and cargo volumes. This is to a large extent due to the impact of the Yamal LNG project during the construction phase and the following export of LNG. But a number of other projects are contributing to this increase as well. Arctic LNG 2 is the immediate future planned for 2022. Due to lack of people and infrastructure, shallow waters and harsh weather conditions, the Arctic is particularly well suited for floating structures which can be built outside the region and floated into position. Arctic LNG 2 being built in Murmansk is one example, and a floating nuclear power station in Pevek another. After Yamal LNG, Arctic LNG 2, then Arctic LNG 1 and 3. Going forward, the Novatek projects are the most publicized, but there are other developments such as Gazprom's Kamennoye-Myrskoye, More, Norilsk Nickel's oil products, and others. When added up, these projects will generate an enormous increase in volumes out of northern Russia and Siberia over the coming 15 years, which can be seen from this graph. In order to be recognized as an international trade route, the NSR needs more regular international users, not least Asian operators such as COSCO. This will over time motivate the construction of more suitable ice-class vessels within all segments. The lack of suitable tonnage is today a major impediment for the development of the NSR. Maybe in the future, pools of suitable vessels owned by different owners could jointly serve the needs of cargo owners. For example, a pool of larger ice-class bulk carriers could serve mineral and mining developments in northern Russia and the Nordic countries together. This would give the confidence to cargo owners and resource project developers that the lack of transportation capacity is not a threat to new projects, and that the costly ordering of dedicated fleets to serve individual projects is unnecessary. Rosatom Logistics is working to establish the Northern Transit Corridor for fast container transport between East and West on a year-round basis. We believe such a project would benefit from collecting and delivering cargo both inside and outside Russia, thereby maximizing the cargo catchment area. For that reason, we have proposed, in addition to Murmansk, that Kirkenes, less than a day's sailing away, could serve as a transshipment port as well. Maximizing the cargo availability is the decisive factor for the success of this project. Along the same lines, large port development plans are underway in Murmansk for a wide range of cargoes. And large-scale construction work is ongoing as we speak. Should Kirkenes see its port infrastructure development as a catalyst to complement the development in Murmansk? Specialized container carriers or multipurpose vessels can then pick up or discharge cargoes on both sides of the border with very little deviation and loss of time. In connection with the reopening of the Sydvaranger iron ore mine, it is planned to increase the bulk port to be able to load Capesize vessels. Why not ice-class Capesize? In the long term, the Siberian rivers will become large arteries for transportation and major sources of cargo for the NSR. An example is that Kazakhstan is looking at using the Ob-Irtysh river system to gain access to the world's oceans via the port of Sabeta. Large chemical plant components from Hyundai Heavy Industries was transshipped at Kirkenes for Tobolsk, Siberia, illustrating how the rivers can work both for the import of equipment and plants and for the export of products. To utilize the potential of the NSR fully, some bold and large infrastructure investments will have to be made. The Chinese Belt and Road Initiative could play a role in that. Not only east-west, but also north-south connections are required to make these transportation systems work. The Arctic has minerals, metals, natural gas, and a great potential for renewable electricity from wind and hydro, including the production of green and blue hydrogen. By combining these input factors, the Arctic could become a platform for green industrial processing. Sustainable shipping solutions combined with short transportation routes to the main markets in Europe and Asia can turn the Arctic into one of the green solutions the world requires. If of interest, I am pleased to share with you an article I have written on the topic named Green Energy and Large Mineral Deposits Provide Sustainable Business Opportunities in the North. It is available from the Yongsan University. One option is direct reduced iron production with natural gas. If carbon capture and storage with CO2 deposition is added, a sustainable solution for Arctic processing of Arctic resources would exist. Here illustrated by the value chain Finnmark. Another solution which has been announced by Europe's largest iron ore producer, LKAB, the steel producer SSAB, and utility Vattenfall, aims to produce absolutely emission-free steel on a large scale in Sweden. The goal is to produce the first fossil-free steel by 2026 using hydrogen as alternative to the coking coal used in blast furnaces. The hybrid project, when fully realized, requires electrical energy equivalent to 1/3 of Sweden's present capacity. This illustrates the challenge of power generation, which will be the same all over the Arctic. Russia has presented one solution in the form of a floating nuclear power plant installed by Rosatom at Pevek in Siberia. Other solutions can be extensive onshore and offshore wind farms in a part of the world with plentiful of wind resources. Our future vision of the Arctic involves higher value processed products such as semi-processed metals and minerals and table-ready fish products, creating more resilience through the commodity cycles, securing stable employment for the more than 4 million people living there. This creates the basis for retaining young people, the precondition for a viable Arctic and the communities, whether indigenous or not. The aim must be to create livable and thriving Arctic societies while supplying the world with environmentally friendly products produced with sustainable technologies. To sum up, The positive trend of the NSR development can be seen from the Center for High North Logistics NSR 2020 map. The volumes are driven by Russian resource development projects requiring destinational shipping both during the construction phase and for exports from the projects. The few tracks from the Mary River iron ore mine on the Canadian Baffin Island, which you see here, to the far east via the NSR indicate some of the future potential if sufficient numbers of suitable vessels would be available. In addition, container transport might increase from a very low level if the Rosatom Logistics Northern Transit Corridor is realized. The main conditions required for the continued growth of the NSR are: firstly, continued resource development. The main driver for developing shipping is always the availability of cargoes. Secondly, infrastructure construction such as ports, power generating capacity, and necessary icebreak availability. Thirdly, availability of ice class vessels. Real interest in the NSR will only come when there are enough ice class vessels to remove the uncertainty regarding its regular use. Russian regulations giving cargo preference to Russian flag and Russian built ships will over time be detrimental for the development of the NSR. A high number of available vessels and thereby competitive freight rates will determine whether cargo owners choose the NSR as a regular transit route. To achieve this, cargoes from Russian Arctic ports must be open to foreign flag and foreign built vessels. If not, the cargo base will not be sufficient to secure enough vessels without long-term contracts. This will become a limiting factor as a liquid market in high ice class vessels is a precondition for the NSR to be dependable and thereby catching the interest of the international business community. To succeed, it is critical to raise the awareness of the potential of the NSR. It is most often the transit potential which is being focused upon by the media and non-Russian cargo and ship owners. It is seen as more relevant for the international shipping community than the destinational shipping. For this reason, the NSR must not be seen as an exclusively Russian affair. This adds to the generally negative attitude to the commercial activity in the Arctic, illustrated by a recent article in the Shipping Weekly, Tradewinds, Say Niet to NSR, by Terry McAllister, the former energy editor of The Guardian. As there is very little knowledge about the economic activity and even less about transportation in the Arctic, it is easy to applaud those companies which make a point of pledging never to use the Arctic shipping routes. Everything that contributes to generating volumes for the NSR benefits all users, such as project developers, cargo, as well as ship owners. Everyone interested in realizing the potential of the NSR and the livelihood of the people of the Arctic have a joint challenge to initiate sustainable economic activity, generate cargo, and preferably two-way traffic on this shortest route between the world's two largest oceans, thereby saving time, reducing emissions, and making sustainable economic activity in the region competitive and attractive. But above all, and most importantly, predictability is key. Thank you for listening.
Well, once again, Mr. Trudy, thank you very much. Following the keynote presentations, we will move on right away to session 1. And the first session will be moderated by Mr. Sang-woo Lee, Director General of the Korea Maritime Institute. We have 3 presentations ready for the first session. Let me invite Mr. Lee. And we also have one more Korean gentleman, Mr. Park Sok-tae Park, one of the presenters of the session 1. Well, good afternoon, everyone. Once again, my name is Sang Lee. I'm Director General at Korea Maritime Institute. Due to the unprecedented for the first time in the history, we are having a very interesting seminar due to the COVID-19 pandemic. So we have obviously offline participants here gathered together, but we also have online participants joining via Zoom platform. If everything runs fine, I would expect nothing more, but obviously, we may bump into some technical difficulties in the middle. So to that end, I'd like to ask for your understanding in advance. And starting the first session of the seminar today, once again, I will be serving as the moderator. As mentioned by Mr. Chudi in the keynote presentation and also highlighted by many others before, the NSR has been almost 10 years that were used and gaining interest. So we had accomplishments. I mean, in the past, of course, it's also true that we had some fantasies and far-reaching hopes. But now we have a better understanding and we can now see more clearly about the way forward. And now, from Russia, we have, of course, they have strategies to accomplish by 2035. So this will, of course, set a kind of a big picture, setting a clear direction for the Northern Sea route to develop. So roughly 3 to 4 years ago, only 6 million tons of cargo transported via the NSR. But of course, this year it will be much more than that. Roughly 33 million, I believe. And in Russia, based on their plan, by 2035, they expect to have more than 130 million tons or so. To look back on the steps we've taken so far, we have a gentleman from Russia, and we will look upon the developments or progress we have for the last 10 years. And the second presenter from China, from COSCO Shipping, will also share with us experience with International Arctic Treasure of Chinese shipping company. And last but not least, in the first session, from Korea, we have one gentleman from Sinocor, also presenting on NSR development progress and plan. So that will wrap up the first session. Okay, then. So for the first presenter of the session, the main results of navigation in the water area of the Northern Sea route in 2020, we have Mr. Nikolai Munko from Russia. Once again, the first speaker of session 1 is Mr. Nikolai Munko, acting head of NSRA Russia. His presentation will be delivered online. Please.
Slide 1. Report by Nikolai Munko, acting head the Northern Sea Route Administration. Assessment of the result of 10 navigation season in the water area of the Northern Sea Route. Dear Chairman, dear participants, the Northern Sea Route is key factor in the development of the Arctic and a major infrastructure project of global importance. Making the Northern Sea Route a truly international and competitive transport corridor is a key priority. The economic growth of the Arctic zone of the Russian Federation is reasonably associated with the implementation of large investment projects for the development of mineral resources. Oil and gas extraction projects play nowadays and will play in the future a fundamental role. But also oil and coal development projects will be implemented. Within international treaties, the Russian Federation, as is a coastal state, has accepted certain commitments in the sphere of providing a set of navigation services in the Northern Sea Route water area. What had been done over the past 10 years in these regards? Slide 2. In updated legislation, the Russian Federation is guided by the norms of international law, including Article 234 of the United Nations Convention on the Law of the Sea of 1982, which provides the coastal states the right to adopt national laws and regulations to prevent, reduce, and control marine pollution from vessels in ice-covered areas within their exclusive economic zone. In order to implement the rights conferred by the Convention, in 2012, the Russian Federation adopted the corresponding federal law. This law created the condition to centralize administration of the Northern Sea route and equal access for interested transporters, including foreign. For the first time, the law sets for the boundaries of the water area of the Northern Sea route. This slide shows the borders of the water area of the Northern Sea route. Slide 3. The law introduced a permitting procedure for navigation of ships in the water area of the Northern Sea route. Rules of navigation in water area of the Northern Sea route were adopted in 2013. The rules specify the order of administration of shipping in area of the Northern Sea route and requirements for vessels, insurance, safety of navigation, and prevention pollution of marine environment from vessels. In the light of experience of sea navigating in the water area of Northern Sea route since 2013, new versions of rule of navigation in water area of Northern Sea route had been adopted in 2020. According to the rules of 2020, the organization of navigation of ships in water area of Northern Sea route is carried out by the Marine Operation Headquarters, a special navigation service established by the state's corporation Rosatom. Headquarters is mandated to ensure icebreaking assistance for ships and escort of ships along the navigable waterways in the water area of Northern Sea route, develop routes for navigation of ships. According to new version of the rules of permission are issued by the Northern Sea route administration in agreement with the Marine Operation Headquarters. Slide 4. This slide shows the areas of hydrographic services, hydrographic surveys of high latitude route for ships with a draft of more than 12 meters that were executed during the period 2011-2020. Slide 5. Hydrographic surveys were performed with the use of ARC 5 ice-class vessels equipped with a multi-beam echo-sounders, which can guarantee full coverage of the strip on the seabed along the route of hydrographic vessels. The nautical charts were updated on the result of seafloor SWOW surveys. Slide 6. Within the framework of the realization of obligation of the Russian Federation, in accordance with the Search and Rescue 79 International Convention, Marine Rescue Coordination Center Dixon and some centers TIXI and PEVEC were established since 2012 in the search and rescue areas of the Arctic seas. During the navigation season 2013, Advanced Deployment Station, outfitted with the necessary equipment to ensure readiness for the emergency rescue operations, were arranged in the port of Dixon, TIXI, PEVEC, and Providenia. Slide 7. The slide contains information about evacuation of a sick crew member from board of the Nikolai Trubyachinsky vessel to the hospital in the port of TIXI and the tactic and technical characteristic of the helicopter that carried out the rescue operations. Analysis of the results on transportation of mineral commodities. Over the past 10 years, the marine terminals of Kara Sea have played a key role in shaping the cargo flow on the Northern Sea route. they provide all oil, gas condensate, oil, and liquefied natural gas export. Slide 8. Active projects. Yamal LNG, Novoportovskoye, Norilsk, Pelyatkinskoye are fully equipped with the port infrastructure. The construction of ports infrastructure of Arctic LNG 2, Terminal Utreniy of Seaport Sabeta, is carried out in line with schedule. The slide shows the LNG terminal in the port of Sabeta. The seaport of Sabeta is designed for marine transportation of natural gas and gas condensate from the South Timbayskoye gas condensate field to Western European countries and to the countries in the American and in the Asia-Pacific region. The LNG terminal in the port of Sabeta was built from scratch on the Yamal Peninsula in the 2013-2018 years. More detailed information about the development of the port infrastructure and icebreaking fleet construction will be provided in the next report. Slide 9. In the period 2016-2019, a fleet of 15 Yamal Max LNG carriers was built for the project. All vessels have Arc 7 ice class. On conditions of short-term freight, Arc 4 and Ice 2 ice class vessels were also used. All these vessels navigating under the foreign flag by the decision of the Russian government are allowed to transport LNG from the seaport of Sabeta until December 30th, 2043. Shipping of the products of the first stage of the plant started on December 8, 2017, the second on August 9, 2018, and with the launch of the third stage of November 22, 2018, the plant reached the planned parameters 16.5 million tons per year. Actual output of the plant turned out to be higher than the design one. In 2019, when all stages of the plant were in operation, the volume of LNG production was 18.4 million tons. The excessive level of capacity was 11.5%. Arc 7 I class vessels operate all year round. Arc 4 and Ice 2 ice class vessels operate only during the summer-autumn period with the time frame established by the rule of navigation. The involvement of the vessel of Ice 2 and Arc 4 ice class made it possible to ensure the uniformity of the export of LNG due to the fact that some of the Yamal Max vessels carried out direct LNG deliveries along the northern sea route to the east to the port of China and South Korea with a long duration of voyages in the summer-autumn period 2019 and 2020. Condensate shipment began in January 2018. For the condensate export, initially the Arc 4 ice class tankers of the SKF Don and Temza-Stern types were used. Slide 10. In 2019, the condensate was transported by two Arc 7 ice class tankers built for the project with a dead weight of 43,000 tons, Boris Sokolov and Yuri Kuchev dead weights on 50,000 tons. From the beginning of operation of Yuri Kuchev tanker, the use of Arc 4 ice class vessels became unnecessary. Since the start of shipment, 45.5 million tons of LNG and 2.2 7.3 million tons of condensate have been exported from the seaport of Sabetha as at December 1st, 2020. Slide 11. Shipment of oil of Novoportovsky field via the Sabetha port's Arctic Gates oil loading terminal began on May 25, 2016. A special tanker fleet of 7 Arc-7 ice-class vessels with a dead weight of 41,000 tons was built for the project. On the slide you can see the first of the Arc-7 ice-class tankers built for the year-round export of oil from the Novoportovsky field. From the May 25, 2016, 30.1 million tons of oil were exported from the Arctic Gates oil loading terminal as of December 1st, 2020. Slide 12. This slide presents the general information of the annual volumes of cargo transportation on Northern Sea route from 2011 to 2020, including transit cargo. In 2020, 30 million and 257,000 tons were transported as of December 1st, 2020. The growth of cargo volume transportation along the Northern Sea route has increased almost tenfold since 2011. Slide 13. The top graph shows the general information of the transit cargo volumes transported along the Northern Sea route from 2011 to 2020. The quantity of vessel transit voyages is shown on the lower graph. In 2020, 1,281,000 tons of cargo were transported as at December 1st, 2020. Total number of transit voyages, 61. 21 of them in ballast. Transit voyage is defined as the sailing of the vessel from the western border to the eastern border of the Northern Sea route, or vice versa, from the eastern border to the western border without freight operations in the port and points of the Northern Sea route. Slide 14. Let me remind you that the rules of navigation in the water of the Northern Sea route established a permitting procedure for the navigation of ships. A function of issue of permissions is imposed on the Northern Sea route administration. This slide shows information about the number of permissions issued by the Northern Sea route administration for the period from 2013 to December 1st, 2020. Slide 15. This slide gives information about foreign companies, foreign flags, which obtained permission for ships navigation in the water area of the Northern Sea route. As evident in this slide, ships from 46 countries worked in the water area of the Northern Sea route from 2013 to 2020. This slide also provides information on the number of applications submitted by foreign ship owners for obtaining permissions for ships navigating in water area of the Northern Sea route. Slide 16. On September 2, 2019, for the first time in the history of the Northern Sea route, a large capacity oil tanker, Korolev Prospect, has crossed the full water area of the Northern Sea route from west to east, using oil LNG fuel as its primary fuel. The transit from Cape Желания to Cape Dezhnev took 7 days and 6 hours. 104,000 tons of crude oil were delivered from Murmansk port to the port of Qingdao, China by this tanker. Slide 17. Conclusions. Over the past decade, a lot of work has been done in the field of construction and modernization of seaports of the Northern Sea route, infrastructure development of the Northern Sea route, improvement of the legislative framework and organization of Arctic navigation. The boundaries of the water area of the Northern Sea Route have been legally established. Construction of port infrastructure for Yamal LNG and Novoportovskoye project have been completed. Construction of a series of 15 Arc-7 ice-class gas tankers of Yamal Max for the Yamal LNG project have been completed. Construction of a series of 7 Arc-7 ice-class tankers for the Novoportovskoye project have been completed. Maritime Rescue Coordination Center in Dixon and the Marine Rescue Sub-Centers in Tiksi and Pevek have been established. At the end of May 2020, the transition from Sabeta to the port of China along the Northern Sea route of LNG tankers Christophe de Margerie and LNG tanker Vladimir Voronin followed lead, confirmed the possibility of substantial increase of navigation window in the eastern sector of the Arctic. The voyages confirmed the reliability and design solution and engineering system, high icebreaking capability and maneuverability performance of Yamal types LNG tankers. At the same time, an analysis of the operation of vessels in the water area of the Northern Sea route revealed shortcomings which should be addressed. It's necessary to improve the quantity of and reliability of communications, to increase the efficiency of such a rescue operation in heavy ice conditions, to ensure timely provision of medical care to crew members of vessels, in order to create conditions for safe navigation for providing rhythmic cargo transportation in the winter-spring period in the eastern direction of the Northern Sea route, it's necessary to continue the practice of performing experimental voyages in the period of heavy ice conditions, February-May. Such voyages allow to identify most accurately needs for icebreaking fleet, to access the functioning of navigational, hydrometeorological, and search and rescue services, and improve the tactics and of icebreaking assistance for large capacity vessels in heavy ice conditions. Slide 18. Welcome to the Northern Sea route. Slide 19. Thank you.
Thank you very much. It was Mr. Nikolai Monko, the acting head of NSRA. He shared the assessment of the navigation for 10 years in the water area of the Northern Sea route, how it started, and he has given us a series of updates on what kind of activities have done and what kind of improvement has been made with regard to the Northern Sea route. And he also touched upon the various challenges, such as the rescue, search and rescue, as well as the communications. Although slowly, well, there has been some improvement. And he also mentioned improvement in terms of the port infrastructure. And finally, he shared with us the direction we have to pursue going forward. Thank you very much for sharing your experience as well as the insight. Then now I'd like to turn to one of the users of the Northern Sea route from China, Mr. Tan Pan, General Director of Coastal Shipping Specialized Carrier of China, will talk about Arctic shipping experience and expectation. Please.
Distinguished guests, ladies and gentlemen, good afternoon. My name is Chen Feng, coming from the Coastal Shipping Specialized Carrier as General Director and a Senior Economist of Marketing and Sales Center. Also as guested professor of Iceland Research Center of the University of Jinan, China. It's my pleasure to show you my presentation about Arctic shipping experience and expectation, including 5 parts. Part 1 about COSCO Shipping Specialized Carrier or Group. COSCO Shipping Group comprises of 1,371 vessels with a capacity of 109 million tons. Our company, COSCO Shipping Specialized Carrier, is core member of COSCO Shipping Group and as the leading company in breakbulk shipping industry on worldwide, owning and operating more than 130 vessels, including semi-submersible vessel, heavy lift vessel, multi-purpose vessel, pulp carrier, fuel car carrier, asphalt carrier, and log carrier. COSCO Shipping Specialized Carrier are ready to offer worldwide shipping service and supply chain logistics service to all customers globally. Part 2 about Arctic shipping practice. We have 33 vessels with 42 voyages completed totally from 2013 to 2020 with shipping via Arctic Oceans. I show you details for each year. In 2020, we had 11 voyages, including 5 westbound and 6 eastbound. In 2019, we have 9 voyages, including 4 westbound and 5 eastbound. In 2018, we have 8 voyages, including 4 westbound and 4 eastbound. In 2017, we have 5 voyages, including 3 westbound and 2 eastbound. In 2013, we have 6 voyages, including 3 westbound and 4 eastbound. We have vessel Yongsheng completed the first single westbound voyage in 2013 and launched the trip of Arctic sailing in 2015. The vessel departed from Taichung, China on 15 October 2013, with arriving Rotterdam on 10 September. It took total 72 days. Part 3 performance. Our vessels are possibly calling in 3 regions. In Arctic regions, we call mainly in Baltic ports like Helsinki, Kotka, Finland, Varberg, Gävle, Sweden, Denmark, Russia, Lithuania. Also possibly to call continental and the UK like Hamburg, Rotterdam. Possibly calling it Icelandic ports and North American ports when clients ask. Also possibly in Arctic regions like Kirkenes, Norway, Murmansk, Sabat, Dudinka in Russia. Also in Far East region, we call mainly in China, Jiangsu province like Taichung, Lianyungang, Jiangyin, Dafeng, mainly for westbound voyage. Also in Shandong province like Qingdao, Weifang, Rizhao ports, mainly for eastbound voyage, as well as calling it Shanghai, Tianjin, Dalian, Guangzhou. Also we call the Tomakomai in Japan and Busan in Korea, and possibly many other ports in Asia, also called in Da Nang, Vietnam. In far east of Russia, some ports like Vladivostok and Nahodok possibly. About the cargo category and the volume shipped by our vessel via Arctic Ocean, we totally carried 1.38 million tons over past year, including such kind of cargo showing on picture. For eastbound from North Atlantic, we carried water pulp, timber, oil concentrate, grain, steel cargo. For westbound from Far East, we carried mainly project cargo, like wind project cargo, railway project cargo, wagon and rail, power plant project cargo, chemical project cargo, oil drilling project cargo. Also other deck cargo like barge, dark boat, yachts, RTG lift. Performance the advantage of shipping. It shortened the transport time with time saving for about 10 days per voyage for consignee to receive goods early. The sailing time for 42 voyages were decreased by 508.5 days. It reduced the emission of carbon dioxide of 45,450 tons. It reduced the fuel consumption of 14,550 tons. It had a cost saving pretty much in comparing with the convention shipping via Suez, when fuel saving, vessel fixed cost saving for 10 days and others. All those cost save looks not a small figure, which has significant economic benefit for MPP vessels sailing via Arctic Ocean. It reduced also the risk of pilot in other area. So you can see the figure about benefit in detail for each year. Also, we make the statistics analyze about voyage. You can see the total voyage for last 3 years, the 2022 for 28, 2,694 for last year, 2,266 for this year until end of October. We divided those in 3 situations. Situation 1, both loading and unloading port within Northern Sea Road. It's about 27. One port, either loading port or discharging port within Northern Sea Road. It's about 2/3. Both port loading and unloading are not in the Northern Sea Road. Its transit voyage, it's quite a small number. 27 for 2018, 37 for 2019, 44 voyages for this year. COSCO has 8 voyages in 2018, 9 voyages in 2019, 11 voyages for this year. It's about 24 to 30% of voyage number. For cargo volume, it's about 40%. Part 4 achievement. A, to follow navigation guidance and QHSE rules is basic for safety sailing. B, it's extremely important to issue and update the operation manual gradually as per own experience. Right side, please find the copy of Polo Water Operation Manual and Heavy Cargo Securing Guide, which was added on basis of our own performance of shipping via Arctic Ocean. Achievement C. The crew member must be trained to acknowledge information about Arctic Ocean and the Northeast Passage, and each voyage should be guided by experienced crews. Achievement D. The company has to create the voyage plan with operating specifications, emerging measures for each voyage before sailing. Achievement E. Its basic requirement to cooperate with partners with icebreak pilot service provider, with information provided of ice condition, weather, and act with emerging assistance. Achievement 5. We are still facing the challenge of shipping via Arctic Ocean. The navigable period via Arctic Northeast Passage is mostly from July to October only, not regularly. The climate of Arctic Northeast Passage is changeable. Shippers sailing with instant information of weather limited. The infrastructure construction along the passage is undeveloped. Reliable navigation information is still limited. Achievement G. Development philosophy. After 7 years sailing experience, we realized to serve international trade between Northern Europe and the Far East smoothly, quickly, green environment protection when sailing, sustainable shipping service in accordance with rules and regulations. Part 5. Expectation about Arctic. The Arctic region usually refers to the area north of the Arctic Circle. It covers a total area of 21 million square kilometers, account for 13 million square meters. The average water area in winter is about 3/4 to be covered by ice, namely 10 to 11 million square kilometers. In summer, it's about 1/2 covered by ice, namely 6 to 8 million square meters. Ice area changed smaller over past 20 years. So you can see in 1999, it's about 6.1 million square meters. In 2009, it's about 5.3 million square meters. Last year, it was 4.3 million. For this year, the smallest ice area is about 3 million even. To develop one information service and scientific research, there are a relative shortage of information in Arctic area, including ice situation, wave situation, climate, rescue capability, maintenance service, emerging medical service. To develop 2 ports, terminal, and rescue capability. Because the cargo volume in the Arctic region is generally small, ports are limited. With the development of industry in the Arctic region, such as Yamal gas in Russia, the demand for shipping and port service is increased, including shipping supply and rescue needed to be increased. Ports to be attentioned, including those Kirkenes in Norway, Finnfjord in Iceland, Murmansk, Sabat, Dudinka in Russia. To develop 3, international cooperation as a nation location closing to the Arctic region, we are hoping to develop international cooperation with while utilization and protection of Arctic area, including cooperation with countries from Arctic region and also out of Arctic region, with the government and civil society for the purpose of scientific research and Navigation Practice Information Service Act. To develop for the window period should be extended with assistance of ice break. The current window period for shipping is about 2.5 months, but it should be extended to longer duration between 4 and 5 months with assistance of ice break to bring more benefit to clients from EU and Far East. Thank you.
Well, once again, Mr. Fang Chen, thank you very much for your presentation. Well, the first speaker, Nikolai Munko, mentioned about their administration's perspective. Now we have an interesting story from the operators or the users' perspective. So there are still a lot of needs for ice-breaking support and also tax benefits, etc. And also for COSCO, as they are the leading shipping company, so they have enough fleet. So it's something we envy. So I think we should also make more efforts to catch up with them. So he highlighted 4 key issues. First of all, about scientific development and information service, and also development of infra and port structures and facilities, and also a need for international cooperation, also support by icebreaking fleet to expand the transportation and navigational period on the NSR. All, of course, so we agree. But for vessels and, of course, for ports, we have quite, tricky situations in relation with environmental concerns. So I think we should wait and see and have a further discussions. Of course, still there are issues not resolved yet. The governance and international collaborations, because each country has a different, interests. Russia, as the, operator of the NSR, they have their own interests, and China and other nations using the NSR have different, perspectives in terms of interests. So, last but not least, regarding the period of transit, so roughly it's 4 months. About 4 months are available for transit, but obviously we have to have at least 9 months of navigational period to have sufficient level of commercial operations. So of course, melting ice is not all that good news to us. It has goods and bads. So I think it was quite interesting to listen to China's experience. Okay, we have one last presentation on the session 1. That's from Mr. Sok Tae-bak from Sinocor on NSR development progress and plan for Sinocor. Okay, Mr. Bak, please. Once again, my name is Sok Tae-bak. I'm managing director at Sinocor. Before I begin, compared to the previous presentation from COSCO, so we are just taking our first step, baby steps compared to COSCO Shipping. They are very experienced, but still, taking this opportunity, I'd like to share with you NSR development progress and plan for Sinocor on the NSR. Okay, the contents of my presentations are as follows: overview, followed by introduction of the Sinocor, and I will move on to the current status of our NSR operation and development. Well, at Sinocor, we were established the Sinocor Company Limited in Hong Kong in 1984. That was the first container liner service between Korea and China. And in 10 years, in 1999, and now we have changed our company name to Sinocor, which is the current company name. And so in addition to China, we extended our services to Japan, the Northeast Asian nations. So Sinokor container liner service currently covers 106 ports across 18 countries. In addition, we have 34 subsidiary companies and local offices. In particular, in 2008, when the international oil market was quite suffering, we completed conversion of the first ship from VLCC to VLOC and sailed with a full loading for the first time. So in Sinokor, we cover not just maritime transportation, we also cover logistical services, including ground, air, and multimodal transportation. So in Sinokor, our main focus of a business is a container service. So it's 63,000 TEU. As you can see on the slide, we have ship operation, 45 container ships. The total capacity is 35,055 TEU. So we also have a CNTR, 26 container ships, total 30,349 TEU. And currently, the container throughput we are dealing with, growing year after year. As you can see on the graph, in 2016, we accomplished 1.5 million TEU, and last year we merged with Hungha, and our throughputs almost reached 30 million. And this year, even though we had difficult situations due to COVID-19, we believe we are going to reach over 3 million TEU. Well, for container liner service, the map shows our service areas. On the east, we have Russia, China, Japan, and on the southern direction, we have Hong Kong, Vietnam, Thailand, Singapore, Malaysia, Indonesia. And to the west, we have Bangladesh, India, and Middle East. We have in total 20 branch offices. Looking more into detail, the service between Korea and Japan, we have Tokyo, Osaka, Yokohama, Nagoya, and we have 8 Japanese ports for our main operations, and Honshu, Shikoku, and we have 41 local ports. So in total, we have 49 ports connecting between Japan and Korea, and we are providing shuttle services 2 times every week. And next, the service between China and Korea. We have in Korea, Incheon, Pyeongtaek, Busan, Ulsan. Those are main ports, and we have 10 local branches in China. So from north, Dalian, Qingdao, Nanjing, Ningbo, and Shenzhen. In the south, we have in total 10 local branches for our container operation. In addition to that, between 3 nations of Korea, China, and Japan, we are constantly operating the container services between these 3 nations. Next, our services in the intra-Asia services, mainly Southeast Asia. So focusing on Vietnam, Malaysia, and Indonesia, we have also 15 countries, including the Philippines, and 39 ports, ranging from 1,000 TEU and more. And in Korea, HMM, KTC, and CMA CGM, POSCO, One Eye, Evergreen, SITC, and other foreign flag shipping companies are working together with us. In particular, Sinokor have 4 Russian operation routes centered on Gwangyang, Busan, and Ulsan. We have 3 operations to Vladivostok and Vostokny, 1 voyage per week, connecting cargoes from Russia via Korea to China and Southeast nations. And the slide shows our organizational charts in our Vladivostok office and Vostochny office. As our subsidiaries, as I mentioned before, Heng'an Line, which is specialized in container and liner services. We have Kugyang Logistics, a container service, and for container management, Pacific Engineering. And we have port operations, PPTN, and for vessel management as well. In addition, we have a depot overseas in China, Shanghai, Qingdao, Tianjin, 100,000 square meters, 14,000 TU, and also in Southeast Asia, 150,000 TU. We are operating our depot stations in China and Southeast Asia. And let us move on to the current status of terminal operations under our company. We have a BPT for Busan Port and GWCT for Gwangyang. In Gwangyang, in particular, we are handling roughly 1 million TEU, and in Busan, roughly 3.7 million. Next, moving on to the development in the Northern Sea route, we are still in the early stage, but for active participation. In September 4th last year in Vladivostok, we signed an MOU together with Rosatom and Korea Maritime Equipment Research Institute based on the principle of a mutual benefit. Let me share briefly with you the main contents of the MOU signed. That is to modernize and develop the infrastructure in the ports, to cooperate to that end, and also for joint research and activities for marketing, to facilitate Europe-Asia trade, and third, an organization of the training systems and to enhance energy efficiency and also change information for ship operation know-how and network development related to operation in the NSR. And our suggestion or the proposal for the future development of the NSR is related to the Far East Asia parts instead of two ends, the strategy of Russia. We are focusing on Busan or Vostochny as a transshipment hub. But the main reason why is that utilizing the existing infrastructure in Busan and Vostochny, we can save time and cost required for new infrastructure development. And in particular, if the route is extended to Busan port, it will further connect other ports in Asia, including Japan and Southeast Asia. So I think it will further promote the active growth of cargo transportation in the region. Last but not least, regarding the increasing environmental concerns in the region, our counter actions or measures against that, as mentioned before by previous speakers, we also plan to develop vessels using eco-friendly fuels. This is the end of our presentation. Thank you for listening. Thank you very much. Well, once again, to Mr. Park, thank you very much. Well, Sinocor is a kind of middle-class player and trying very hard. We also know that you are making great efforts to actively participate in the shipping and logistics operation in the NSR, and you shared with us your experience and your future development plan on the NSR in particular, and also how to connect with the Far East Russian regions. Well, initially, via online, we plan to take questions, but looks like there's no questions collected. That's the information I received. But if you have questions from the floor regarding the presentations made in the first session, we have 3 speakers. So once again, but I'd like to ask for your understanding that because we had some pre-recorded presentations. So if you have questions, we will deliver them via email to the speakers. Okay. Looks like there's no question from the floor. All right. For the first session, of course, we had from a supplier's perspectives in Russia, and we also heard about the user's perspective from China. And third, one of the Korean shipping company, Sinocorp, what kind of interest they have and what kind of plans they have to develop their logistics operation in the NSR. So we had 3 interesting presentations in the session 1. I hope that this serves as a really good starting point. We can have a further development in the NSR and have more interesting discussions in 10 years from now. So with keeping that in mind, I will wrap up this first session. Thank you very much. We just closed the first session 1, and we will take a quick break, and we will start session 2 at 3:20 Korea time.
Ladies and gentlemen, let us begin the second session of the 9th International Arctic Shipping Seminar. The second session is about Arctic shipping infrastructure and environment. We have speakers from Canada, Russia, and Iceland. The second session will be moderated by Mr. Ho Chul-Borg, who is the Vice President of Global Port Authority. Please welcome him with a big round of applause. Good afternoon, ladies and gentlemen. I am Ho Chul-Borg of Busan Port Authority. This session is about Arctic shipping infrastructure, and we will take a look at the current status of the infrastructure and how to develop the infrastructure. The session will go on for the next 70 minutes or so. The three speakers, luckily, are well versed in this area. They are in the field, and before I joined the session, I went through the presentation materials. I came to see that they are quite practical and up to date. And the theme of this seminar is the past, present, and future of the Arctic shipping route. And I think the three presentations are well aligned with the overall title and the theme of the seminar. We have three speakers. And the first speaker is Mr. Drummond Fraser, who is a Maritime Safety Policy Advisor of Transport Canada. And his presentation will be followed by Mr. Mikhail Balkin, who is a State Policy Director of Rosatom of Russia. And last but not least, we will have the presentation to be delivered by Mr. Hafstein Helgason, who is the Director of Business Development and R&D EFLA of Iceland. And if you have any questions, please save them until the end of all presentations. Let us start with the first presentation by Mr. Drummond Fraser.
Good afternoon, colleagues. My name is Drummond Fraser, and I'm a Senior Policy Advisor at Transport Canada within the Marine Safety and Security branch. I'm going to spend the next 20 minutes or so talking to you today about planning a voyage and navigating the Northwest Passage. And it's my hope that this will provide an interesting counterpoint to the discussions surrounding the Northern Sea Route. Before I get into any of the nuances or the specificities or the things that make Canada's Arctic shipping regime perhaps a little bit unique, I think it's important to provide a little bit of context, as simple as this may be. So, what are Canada's Arctic waters? Well, they're defined in the Arctic Waters Pollution Prevention Act. And the definition sets out those areas north of 60 degrees north and out to the extent of Canada's exclusive economic zone. And that extent is noted in the image on your left that's highlighted in pink. Now, what's not highlighted, but what's equally important to be made aware of, is that the network of islands that together comprise Canada's Arctic archipelago are also the internal waters of Canada, and accordingly subject to Canada's complete sovereign and unfettered control. Those waterways also comprise what are often referred to as the Northwest Passage or even the Northwest Passages. It's important to note here as well that there's no one definition of the Northwest Passage. Instead, it is a series of routes, upwards of 6, 7, 8, that meander through this archipelago, connecting the Atlantic to the Pacific Oceans. Canada's Arctic shipping regime is rooted in the Law of the Sea Convention. Indeed, its pollution prevention regime is linked very closely to Article 234 of the Law of the Sea Convention on ice-covered areas, which set forward pollution prevention regimes seaward of the baselines. I'll also note that the geographic scope of Canada's Arctic waters is also encompassed within the definition of the Arctic as set out under the International Maritime Organization's Polar Code. I had already mentioned that the definition of Canada's Arctic is set out in the Arctic Act, or the Arctic Waters Pollution Prevention Act, which was established in 1970. So Canada has close to 50 years of experience in regulating its Arctic waters. The Arctic Act was and remains unique for a host of reasons, not least of which is the very upfront recognition that the Arctic, Canadian Arctic specifically, is a homeland to generations of Inuit. And that it is also a region with a very unique ecological balance. And these are two sort of tenets that run central throughout Canada's Arctic shipping legislation and regulation. In 2017, when the International Polar Code entered into force internationally, Canada's Arctic shipping regime received a significant overhaul to reflect, in many cases, the negotiations that happened at the international level. I'd also like to flag the fact that Canada's Arctic shipping regime does not occur in a vacuum. In other words, the provisions that are set forward are very much linked to the operational realities of shipping in the north, of shipping at distances remote from shore-based facilities, of shipping at high latitudes, of shipping in difficult ice conditions. So there are a variety of very specific and or unique hazards that together account for the realities of shipping in the Arctic. You can see a list of some of them to the left of this slide. And indeed, these are hazards and associated risks that are set out in the earlier chapters of the Polar Code. Over the next couple of slides, I'm going to now just dig a little bit deeper into a handful of some unique provisions that mariners, that seafarers should be made aware of when operating within Canada's Arctic. And those provisions include a suite of operational methodologies, reporting requirements, and heightened pollution prevention provisions. The first ice operation methodology that I'd like to draw your attention to is one of the oldest, and it's called the zone date system. And I can concede that the images on your right are probably quite difficult to discern, but I'll do my best to explain it. What the zone date system does is it effectively carves the Canadian Arctic up into 16 discrete zones that are based on historical ice conditions, with Zone 1 having a greater degree of ice concentration, a more difficult ice regime, if you will, and Zone 16 having lower degrees of ice concentration. Accompanying that image with the 16 polygons is a table. And again, a modified version of that table is on the screen in front of you. And what that table does, it establishes a range of vessel ice classes and identifies specific times of the year when vessels built to a particular ice class can operate within any one of the 16 identified zones. So again, these two, the table and the map, are meant to be used together. The zone date system is a useful tool largely for voyage planning. It's because it has drawbacks in that this is a static system. It's not dynamic. It is not reflective of actual prevailing ice conditions. But for the purposes of getting a general sense of the type of vessel that you're looking to operate, you can get a good appreciation for where within the Canadian Arctic you can go. The second ice operation methodology that I'd like to draw your attention to is called the Arctic Ice Regime Shipping System, or AIRS. In the context of Canada's Arctic shipping regime, this system is applicable to any vessel that's built before the 1st of January 2017 that's operating outside of the allowable dates of the zone date system. It's also applicable to vessels that are not built to a polar class. The underlying principle of the AIRS system is essentially an evaluation of risks posed to the vessel by prevailing ice conditions. And in order to determine the prevailing ice conditions, the AIRS system requires that trained personnel be on board the vessel who are able to identify ice regimes based on, again, visual observations, aerial reconnaissance, reviewing of ice charts, any number of variable inputs. AIRS is essentially a very simple calculation wherein what's called an ice numeral is generated at the end of performing that calculation. And if that ice numeral is positive, then the vessel is deemed appropriate to be operating within the ice regime and may proceed accordingly. Whereas if the ice numeral comes out as negative, then the captain needs to reevaluate its position in ice, and that could take on the form of requesting ice escort or taking an alternate route altogether. In order to generate an ice numeral, you need what's called an ice multiplier, and there is a standard within the Government of Canada that sets out the range of unique ice multipliers that are assigned to different types of ice regimes and different types of vessels based on their degree of ice strengthening. So the image on the right is really just a performance of a simple ice numeral calculation. And again, here is the table of AIRS ice multipliers that I had mentioned in the previous slide. It's inclusive of vessels built to sort of extreme levels of ice strengthening, Polar Class 1 being at the top of the pile, whereas it's also inclusive of vessels that don't have any degree of ice strengthening, which are, in the case of this regime, considered a Type E vessel. The third and final ice operation methodology that I will describe is called the Polar Operational Limit Assessment Risk Indexing System, or POLARIS. Now, this is a methodology that is supported, if you will, by the International Maritime Organization. A circular was issued about 4 years or so ago that referenced POLARIS as an example of an appropriate ice operation methodology to use in the context of the Polar Code. So what Canada has done is effectively incorporated this regime into its domestic regime and has said that any vessel that is built after the 1st of January 2017 must use POLARIS, again, if operating outside of the allowable dates of the zone date system, or any vessel that has been assigned an IAX polar class must use POLARIS. Now, POLARIS uses World Meteorological Organization nomenclature and builds upon both the AIRS and the Russian ice passport systems. And much like AIRS, a simple calculation is performed wherein, rather than an ice numeral, what you are presented with is what's called a risk index outcome. And depending upon the numerical value of this risk index outcome, that determines the type of operation that should occur. So you'll note there's a small table on the bottom right-hand side of this slide. This is actually reflective of Canadian regulation. And I think it's worthwhile just to quickly highlight. And that notes that if your RIO is greater than 0 and you are of a PC3 to PC7 class, you may proceed as you would otherwise normally. Same thing with vessels built to any other ice class. If, however, your RIO is between 0 and -10, then PC3 to PC7 class vessels must proceed with what's called elevated operational risk and be subject to any unique provisions set out in the vessel's unique Polar Waters Operational Manual. And that could be anything from speed reduction, for example. However, for other vessels that are not built to a PC class, if the RIO is between -10 and 0, then they are denied entry. And for all vessels, if the RIO is below -10, there's also no entry. Now, much like Eris, Polaris has a table of risk index values, and you can see that modified version on the slide in front of you. Another unique provision of Canada's Arctic shipping regime is the Northern Canada Vessel Traffic Service Zone, or NORDREG as it's referred to in its shorthand. NORDREG is a system whereby vessels must report to the Canadian Coast Guard upon entry into the Canadian Arctic. Indeed, the geographical range covered by NORDREG is actually a little bit larger than the definition of Canada's Arctic, in that it also extends to include the entirety of Hudson Bay, as well as James Bay and Ungava Bay in northern Quebec. NORDREG, in addition to requiring advance notice, also requires daily reports, as well as sort of a suite of other reporting conditions based on the type of vessel and the type of activity that the vessel is engaged in. In exchange, the Canadian Coast Guard does provide the vessel with the most current ice information, domain awareness information, proximity to Coast Guard assets. So it is a bit of a two-way street. The last element of Canada's Arctic regime that I would like to make mention of concerns the heightened pollution prevention requirements. Now, the Arctic Waters Pollution Prevention Act sets forward a complete or zero discharge regime on ship source pollutants from entering the water column of Canada's Arctic, except where authorized by regulation. So, under the Arctic Shipping Safety and Pollution Prevention Regulations, a number of the elements of Part 2 of the Polar Code that concern pollution prevention have been brought into force domestically, though not all. Indeed, under Canada's regime, the environmental provisions are even more restrictive than what the Polar Code sets out. So, sewage, for example, may be discharged provided it is treated and provided it is done at set distances from ice. The sewage discharge allowances under the Canadian regime extend to include all types of vessels, not just vessels that are certified in accordance with the appropriate MARPOL annex. Similarly, allowances for discharge are only granted if the garbage is organic and disposed of at certain discharges from ice. And once again, it's applicable to all types of vessels, not just those that are subject to the appropriate MARPOL annex. I'd like to quickly turn away from some of the roles and responsibilities that Transport Canada has as a federal government regulator in the Arctic, and focus my remaining few slides on some of the additional federal government departments and agencies in Canada that have roles and responsibilities for Arctic shipping, not least of which is, of course, the Canadian Coast Guard. Now, I do not claim to speak on behalf of or represent the Coast Guard, but I would certainly be remiss if I did not draw attention to the good work that they do. Program activities include icebreaking, marine communications and traffic services, aids to navigation, as well as incident management, which includes search and rescue and environmental response. This past summer Arctic shipping season saw the deployment of 8 Canadian Coast Guard icebreakers into the Canadian Arctic. You can see their departure and return dates, as well as the number of days spent in the Canadian Arctic and the types of programs that they were engaged in on the slide in front of you. You'll note that the departure and return dates generally reflect the summer Arctic shipping season in Canada, So from late June, early July, through till mid to late October, although the last Canadian Coast Guard icebreaker to depart the Arctic was on the 11th of November. This second Canadian Coast Guard slide provides an illustration of Canadian Coast Guard Auxiliary Unit stations and proposed stations on the left-hand image. On the right-hand, pardon me, are two tables that are drawn from NORDRAG reporting data from 2019 and 2020. The top table provides a high-level impression of the number of individual ships that operated in the Canadian Arctic this year and the number of individual voyages that were undertaken by these ships. And you'll note that there was a significant decrease in both from the previous year. You'll also note that in 2019, the number of Northwest Passage transits was at 28. And in 2020, that had decreased significantly, over 70%, down to only 8 transits. This can be attributed to a variety of reasons, not least of which was the Canadian government's prohibition on both pleasure craft and passenger vessels from operating within the Canadian Arctic during the summer months on account of an abundance of caution for reduction in spread of COVID-19. You'll also note that in the table below, which provides a breakdown of all the individual types of vessels that operate in the Canadian Arctic, that the significant majority are bulk carriers, and those are bulk carriers that are transiting in and out of the Baffinland or Mary River iron ore mine in northern Baffin Island. And second to those bulk carriers are fishing vessels, again, the majority of which are located in the Eastern Arctic, operating between Baffin Island and Greenland in the Baffin Bay Davis Strait area. I'd also like to quickly draw attention to the Canadian Ice Service. Canadian Ice Service provides a range of services to mariners throughout the entirety of Canada. But in the Canadian Arctic, they provide nowcast and forecast ice and iceberg information 365 days of the year. They also engage in monitoring of Canadian Arctic waters for pollution incidents using satellite data. There are 4 images on the right-hand side of this slide, which are weekly, a composite of weekly ice charts issued in early June and early September. And you'll note that the top 2 images of the Eastern Arctic provide you with an impression of, again, ice at the beginning of the season and ice at the end of the season. So there's a reasonably significant reduction, though the waters aren't ice-free. Now, compare that to the bottom 2 images of the Western Canadian Arctic in and around the Beaufort Gyre, and you'll see that middle of June, there are significant concentrations of ice that persist. And fast forward through to the middle of September, while ice along the coast has receded, there nevertheless remains significant concentrations of ice along Banks Island, along much of the Western Arctic archipelago. And indeed, when you look at some of the notable events from this past summer, in both the eastern, western, and southern approaches to the Canadian Arctic, ice melt was earlier and freeze up was delayed. So this is representative of a general trend that we tend to see within the Canadian Arctic, though certainly there are aberrations and anomalies in any given year. The final federal government organization with involvement in the Canadian Arctic that I'd like to draw your attention to is the Canadian Hydrographic Service, who are responsible for, amongst other things, charting and bathymetric work, not just within the Arctic, but on all 3 of Canada's coasts and internal waterways. And this is a bit of a daunting task, particularly when you look at the Canadian Arctic and the entire continent of Europe can fit nicely over top the Arctic archipelago, and there would still be room to spare. So it's quite a significant geographic range of waterways that need to be charted. So in order to try to prioritize efforts, given limited assets, the Canadian government has embarked upon a concept of identifying low impact shipping corridors. And these corridors are in turn ranked according to a range of criteria, to primary, secondary, tertiary, et cetera, et cetera, et cetera. You can see the eastern Canadian Arctic in the image on the left, and those areas that have been designated primary, secondary, tertiary, et cetera. And from 2017, 23% of primary and secondary shipping corridors were charted to modern, which is CATSOC A1 and A2 standards. Whereas in 2020, this summer, that number was brought up to 33%. So a 10% increase in 3 years. The vast majority of bathymetric information comes from the Canadian Coast Guard vessel, the Amundsen, which has been in operation since 2003. And indeed, she's responsible for over 50% of all modern hydrography in the Canadian Arctic. So really a true workhorse. Now, in order to try to address the issue of limited assets and the sheer volume of work that needs to be done, a variety of innovative approaches to acquiring data are being employed, including equipping recreational vessels with qualified multi-beam operators who understand charting standards, as well as employing autonomous vessels to do unmanned bathymetric work. Finally, in conclusion, I'd like to depart with a few remarks. The first of which is that Canada has a robust vessel safety and pollution prevention regime that's rooted in the Law of the Sea Convention. It's a regime that is reflective of International Maritime Organization Convention and one that's tailored to the unique hazards and the associated risks of vessel operations in Canada's north. It's also a regime that recognizes the rights of local Inuit who've called the Arctic home for generations. Indeed, Canada welcomes navigation in its Arctic waterways, provided vessels comply with rules related to safety, security, and pollution prevention, a number of which I've flagged and highlighted during the earlier half of this presentation. It's my personal view that despite advances in ship technology and despite a general trend of reduction in sea ice extent and thickness, particularly in the shoulder seasons of the Canadian Arctic summer, the Canadian Arctic will continue to pose unique risks to mariners, which serves to underscore the critical importance of training, particularly for those who are unfamiliar with Arctic operations. Also, vis-a-vis the Northern Sea route, Canadian Arctic shipping numbers are generally lower. Canadian Arctic shipping generally is associated with what's called destination shipping. So it is vessels that are departing ports south of 60 degrees north and entering ports north of 60 degrees north to carry out a number of activities, including resupplying local communities with food and fuel, providing services to local mine sites, engaging in fishing activity. And it's not so much vessels using the Northwest Passage or Northwest Passages as a transit route or a shortcut between the Atlantic and the Pacific. Certainly that's not what we're seeing in the numbers reported. And then finally, the 2020 Arctic shipping season was very much a unique one on account of the global COVID-19 pandemic, with temporary prohibitions having been put in place that have all but limited passenger vessel and recreational vessel activity from occurring within the Canadian Arctic. It's effectively limited or postponed virtually all research activity, vessel-based research activity in the Canadian Arctic. And these prohibitions are currently in place until further notice. So 2021 could very well be a different year. So with that, I'd like to conclude and thank you very much for your patience.
Well, once again, please give hands, big hand to the presenter. Well, I believe Mr. Fraser could not hear the big applause here in Busan, but it was really insightful and interesting presentation. A lot of valuable information shared. Thank you very much. So hearing the presentation, in particular in the conclusion, well, I was planning to give some comments, but well, it was really realistic data and information he shared with us. If you look at the fourth, the Northwest Passage, the data he shared with us mostly. Well, the vessels are traveled between the Northwest Passage. The destinations are almost always Canada, so I mean it's not via Canada to US and other destinations. So as you already know, in the year 2020, due to the COVID-19 pandemic and other reasons, there's a prohibition of transportation or navigation of cruise vessels and recreational vessels and others. So, including myself and others, are very interested in the NSR in the last part of the presentation and to secure the safe navigation of vessels in the ice water. The four measures taken by the Canada Transportation Authorities so obviously shows that how scientific and systematic the measures are implemented by the Canadian authority. And all the detailed information, and maybe you can clearly refer to, but the shipping companies actually working or operating in the NSR, the ZDSR, and Polaris, Ares, and other items and systems already in place in the Canadian, Arctic route. I think it will be quite helpful to take them into account. Once again, thank you very much, Mr. Fraser. And we are moving on to the second presentation of the session 2. That is about Northern Sea Route, current and future development. The speaker is Mr. Mikhail Balkin. He's the State Policy Director of Rosatom in Russia. I think I remember his face, so that means that he has participated in the seminar for several years. One of the regular speakers, I'm not sure he can see us, but please give a big hand to Mr. Balkin.
Dear ladies and gentlemen, good day. First of all, I am very glad to participate in the International Arctic Shipping Seminar again. The seminar now has almost 10-year history and proved to be ground for professional discussion of questions related to shipping in high latitudes, innovative technologies of navigation in ice conditions, rapid growth of economic significance of the Arctic, and ways to preserve its fragile nature. Representatives of business, science, shipbuilding industry will be sharing their views on the development of Arctic maritime routes for safe and sustainable navigation. I would like to thank the organizers of the seminar that they managed to host it despite the pandemic of COVID-19. Let's just hope that we shall be able to meet at the 10th anniversary seminar in person as usual. The topic of my presentation is Northern Sea Route, current and future development. And I am going to speak about the recent changes in Russian legislation in the sphere of Arctic in general and the Northern Sea Route in particular. The development of the atomic icebreaking fleet as the key element to safe and sustainable navigation of the Northern Sea Route will also be mentioned. In the year 2018, the state corporation Rosatom was awarded the status of the infrastructural operator of the Northern Sea Route. Here on the map, the Northern Sea Route boundaries are shown according to Russian legislation and marked light blue. The Northern Sea Route includes the Kara Sea, the Laptev Sea, the East Siberian Sea, and the Chukchi Sea, and lies within Russian exclusive economic zone. There are two Rosatom companies that operate on the Northern Sea Route constantly. This is the operator of the state-owned atomic icebreaking fleet, Rosatomflot, based in Murmansk, and Hydrographic Enterprise, based in St. Petersburg, that produces hydrographic measurements of depths on the NSR and builds state-owned infrastructure of maritime ports. Rosatom also has plans to realize a number of commercial projects related to the Northern Sea Route shipping, which will be launched in the nearest future. Rosatom, together with several federal ministries, governments of Arctic regions of Russia, and commercial companies that do business on the Northern Sea Route developed the Northern Sea Route Infrastructure Development Plan till the year 2035. The plan was adopted by the order of the government of Russia. The plan suggests 3 stages of the Northern Sea Route development. Stage 1 is dedicated to the accelerated development of the western part of the Northern Sea Route in 2019-2024. The Northern Sea Route development at this stage is aimed at the results stated in the decree of the President of Russian Federation dated May 7, 2018. Stage 2 is devoted to the organization of the year-round navigation via all the Northern Sea Route in 2025-2030. After the tasks of this stage are fulfilled by 2030, the Northern Sea Route will become a year-round transportation system, which provides for basic needs of the route's transport services consumers. Stage 3 is dedicated to establishing a competitive international and national transport corridor based on the Northern Sea Route in 2030-2035. By the end of the year 2035, the Northern Sea Route will become the basic element of a competitive international and national maritime transport corridor, capable to meet any needs of the consumers of transport and logistics services. I would like to mention that the international transit navigation via the Northern Sea Route keeps growing. This year, the total volume of transit shipping via the Northern Sea Route is above 1.2 million tons, which is almost twice more than previous year. More than 70 commercial vessels, many of them are 75,000 tons deadweight and more, use the opportunity for faster passage from Atlantic to the Pacific Ocean and vice versa that the Northern Sea Route provides. The plan has 84 activities, which are divided into 11 sections. While preparing the plan, we tried hard to take into account all main spheres of the development of an international maritime seaway to the corresponding standards. The plan thus covers not only commercial issues, but also safety of navigation, communication, modern technologies, weather conditions monitoring, ecology, energy production, and so on. Here is the list of all sections that are included into the Northern Sea Route Infrastructure Development Plan. There are activities aimed at the development of seaports and terminals. Activities aimed at the development of emergency response and rescue and auxiliary fleet. Activities aimed at the development of navigational and hydrographic services of navigation on the Northern Sea Route. It is the absolute must for the heavy tonnage vessels with deep draft to have confirmed fairways where they can keep good commercial speed. Activities aimed at the development of ice-breaking fleet, without which the year-round navigation will not be possible at all. Activities aimed at stimulating the development of cargo traffic and international transit navigation via the Northern Sea Route, including construction of maritime logistics centers. Activities aimed at the development of air and railroad infrastructure to provide cargo base for the Northern Sea Route. Further sections are dedicated to activities aimed at the provision of the safety of navigation and stable communication on the Northern Sea Route. Activities aimed at the development of power production facilities that support the infrastructure of the Northern Sea Route. Activities aimed at the medical provision and personnel training to support the development of the Northern Sea Route infrastructure. Specific Arctic conditions, especially when navigating in ice-covered waters, require special knowledge and training of a master and his crew. Activities aimed at the development of national shipbuilding industry to provide for the needs of Arctic navigation. Activities aimed at the ecological safety of the Northern Sea Route. As I mentioned before, Preserving the fragile ecology of Arctic when major resource extraction projects are launched and the number of vessels transporting their products is growing exponentially is the priority issue. In October 2020, the strategy for the development of the Arctic zone of the Russian Federation and national security up to 2035 was adopted by the decree of the President of Russian Federation. The strategy comprises main statistical data, problematic issues, directions for the development of the Arctic zone of Russia, and details on particular steps. The document covers many aspects of Russian Arctic, like regional and local living conditions, commodities, industry, transport, security, ecology, availability of public services, and so on. Many of these aspects the strategy connects directly to the Northern Sea route. The very first article says that the special approach to social and economic development of the Arctic zone is determined by the strong geographical, historical, and economic connection with the Northern Sea route. It also states the significance of the Northern Sea route as a transport corridor of world scale used to transport national and international cargoes. The traffic through the Northern Sea route rose from 4 million tons in 2014 to 31.5 million tons in 2019. At the very same time, the strategy says that the pace of the development of infrastructure is slower than that of economic development. But this is exactly what the plan for the infrastructural development, which was described earlier, is meant to solve. The strategy is divided into 3 stages: from 2020 to 2024, from 2025 to 2030, from 2030 to 2035, and contains elements incorporated into the Northern Sea Route Development Plan. The map on the right side of the slide shows the areas that comprise the Arctic zone of Russia. In September 2020, the new rules of navigation on the Northern Sea route were adopted by the decree of the government of Russia. The new rules of navigation on the Northern Sea route specify the role of the Maritime Operations Headquarters, which is set up by the state corporation Rosatom in order to organize the navigation on the Northern Sea route. The Maritime Operations Headquarters is run by Atomflot in Murmansk. The headquarters provide the following services: icebreaking assistance to vessels navigating the Northern Sea route, information services to vessels navigating Northern Sea route, navigation routing on the Northern Sea route. The headquarters also positions icebreakers on the Northern Sea route and approves permissions for navigating the Northern Sea route, which are applied to the administration of the Northern Sea route of the Ministry of Transport of Russia. The headquarters processes data received from satellites, meteorological stations, icebreakers, and commercial vessels, and then provides recommendations to the vessels. The headquarters has the proprietary automatic managing system, which is used to organize the navigation on the Northern Sea route. This system is upgraded based on the latest technological and digital solutions. The rules also contain some changes to the requirements to the vessels navigating the Northern Sea route. On the right side of the slide, there is a picture of the maritime headquarters of Atomflot in Murmansk. On this slide, you can see the schedule of new atomic icebreakers commissioning. All icebreakers on this slide are already under construction, except for the first universal atomic icebreaker Arctica, the upper one, which is already commissioned. So now we have 5 atomic icebreakers in operation, including the first universal icebreaker of 60 MW propulsion power. The other 4 universal icebreakers will be delivered in the upcoming years, with the last one scheduled in 2026. At the very same time, the atomic icebreakers that are operated now will gradually be put out of service due to run out of power plant resource, apart from 50 лет Победы icebreaker, which was commissioned in 2007 and is still quite young. Just to remind that they are called universal icebreakers because they can change their working draft and can operate both in deep and shallow waters. In 2027, the first atomic icebreaker of Leader type will be commissioned. This icebreaker will be the most powerful one ever constructed, with a propulsion power of 120 megawatts and icebreaking capability of 4 meters. The Leader type icebreaker is scheduled to operate in the eastern part of the Northern Sea route, where ice conditions are traditionally much harder compared to the western part, the Kara Sea. This icebreaker, together with the universal atomic icebreakers, will ensure the stable navigation through the eastern part of the Northern Sea route on the year-round basis, thus making the NSR operational 365 days a year. By 2027, Rosatom will be operating 7 nuclear-powered icebreakers. As I mentioned before, the first universal atomic icebreaker Arctica in the series of 5 was commissioned on October 21st this year in Murmansk. In this picture you may see this icebreaker in action. The icebreaker is now working on the Northern Sea route and already assisted several cargo vessels. There are several important features that differ this icebreaker from the previous generation. First of all, she is stronger than any other icebreakers operated, 60 megawatts propulsion power. This parameter determines the thickness of ice which the icebreaker can surpass, 3 meters in this case. Previous generation atomic icebreakers limit was 2.3 meters. The ability to rapidly change draft up to 3 meters, called the double draft, allows this icebreaker to operate in heavy ice conditions where bigger mass is required and in shallow waters, like for example Yenisei River. Previously Atomflot could only send 2 out of 4 icebreakers to shallow water areas, and the same proportion was true for heavy ice. Now the universal icebreaker can perform duties in all types of conditions. This icebreaker also has twice less number of crew compared to previous generation icebreakers, due to automation of many operations. This is all that I planned to cover in my presentation. Before I finish my speech, I would like to once again express my sincere gratitude to the organizers of the seminar, especially to the Ministry of Oceans and Fisheries of Korea and the Yonsei University. And I would like to thank the audience for your attention and for your interest towards the Northern Sea route. During the last several years, we have witnessed significant changes of this maritime highway. But this is just a beginning. Should you have questions or comments, please send them to the address shown on this slide. Thank you. Until next time. Goodbye.
Thank you very much, Mr. Mikhail Velkin. He shared with us the Northern Sea route, current and future development in different phases. He mentioned infrastructure several times. And as for the challenges with regard to the infrastructure, would include the ports and harbor in the NSR region. And in case of any accident, well, there is not enough rescue assistance, and the rescue and search center will be built to address that. And last but not least, he mentioned the icebreakers, the assistance of the icebreakers. So those four things will be the main pillars for the infrastructure improvement. He also mentioned 3 different stages for development. Stage 1 would be by 2024, the continuous development of the NSR. And the second stage will be from 2025 to 2030. And that is to complete all the infrastructure construction so that we will have year-round navigation. And in stage 3 or phase 3, from 2030 to 2035, for international shipping transportation, well, that will ensure that the freight will be competitive. So quite an ambitious development plan he just shared with us. And as for nuclear icebreakers, he also elaborated on the plan to provide more nuclear icebreakers. And then probably on the 21st of October this year, I think it was Arctic 7 or something. I think about that, those 6 vessels were built in Korea, so nuclear icebreakers will be continued to be built going forward. And I think you'd agree with me that by when, you'd wonder by when we will be able to commercially use the NSR and around what time it will be feasible. Many people pose questions about that. Mr. Belkin said that by 2035, we will be able to see year-round navigation via Arctic shipping route. Thank you very much, Mr. Belkin. Now I'd like to turn to our 3rd speaker, who is also the last speaker of this session. And this presentation is on the infrastructure development plan for Arctic container shipping. Mr. Hafstein Helgason from Iceland, who is the director of EFLA, will deliver his presentation. And I think his presentation is mostly on the PPP project by Finnafjord. Let us give him a big round of applause for his presentation.
Ladies and gentlemen, thank you so much for inviting me to have this speech on your interesting conference in Busan in Korea. I'm sorry not be able to participate in person. I would very much like to, but due to the pandemic situation we have on Earth, I have to be at home. But anyhow, today I will tell you a little bit about infrastructure development plan for Arctic container shipping. At least from our point of view, that means from the point of, from our view as developers of the Finnafjord port project. I'm a business development director and director for research and development projects at Epla Consulting Engineers. History tells us it is the best to predict and plan actions based on scientific work. We can see this nowadays in the COVID-19 pandemic, how important this is. And when it comes to prediction regarding Arctic shipping and infrastructure investment, we should do absolutely the same. It is of fundamental importance not only to monitor and to do best to understand changes happening in the Arctic. We have to undergo those changes. We have to stay in the area, feel these changes on our own skin. And therefore, only projects when you involve local people, local governance, local engineering and design offices, local people into your projects, that is the only way to succeed. The German Mosaic expedition, which was mainly ongoing last winter, as the Polarstern, the icebreaker Polarstern from Germany, was staying over winter time in the polar ice shield, close to the North Pole itself, with scientists from many nations doing research work. We saw how much things are in movement. The ice there was thinner than planned. All over water to sea, cracks to sea. They had to move measurement equipment due to movement of the ice. They lost part of their equipment. And this is all happening now and happening very fast. This is all about energy flows. And to understand this situation and to have a good understanding of the future, we have to know what is happening in this area. And first we should know that warmer water will rise, is lighter than not warm water. And salinity in the sea water makes water more heavy than water without salt. And we have here in the North Atlantic, we have the 10,000 kilometer long Gulf Stream bringing energy up to the north. We are talking about a flow of 100 million cubic meters per second, and the speed is around 2 meters per second in average. This is changing everything. And the energy in this flow is equivalent to energy from 1 million nuclear power plants. And of course, when so big part of the ocean is in movement and goes up to the north, something has to go towards south. And that is the cold current, which goes from the north down to the south in the deeper sea, let's say. And that is happening between Iceland and Greenland and Iceland and Norway. This is, so to say, a largest waterfall on Earth, something with 15 kilometers wide stream and 4 kilometers steep stream. And is, of course, pulling up then the hot and the warm sea up towards the north. This is, so to say, a machine. And in the summertime, we have higher air temperatures in the area, but we still have the warm sea. And from underneath, the ice is melting much, much faster than melting from the surface through the warm air. And then in the summertime, we have winds blowing from east to west, normally in the polar area, and we have the currents rotating the ice in the polar area. That means we have the oldest ice, all ice we call multi-year-old ice. We have that stored up in the northeast part of Greenland and northeast part of Canada. And when the polar ice cap and the glacier of Greenland will melt, of course, salinity of the water will change. It will fall. And the density of the seawater will also change. It will go down. And the Gulf Stream may, therefore, go into some kind of a slow motion or could even come to a stop. But those climate changes, Earth now, really, we do measure this, may compensate that effect. So this will take this, let's say, warm period will maybe take longer time than normally. But if the Gulf current comes to a stop or goes to a slow movement, then we will have an ice age here up in the north. How deep the sea is under the ice in the polar area. You can see that on the map here. And you can see that towards northeast from Greenland, there is a rather narrow corridor connecting this central pole area with the North Atlantic area. And there, the big cold flow goes towards south. We will see ice-free times during summer, and those summer, they will be longer in future, maybe up to 6 months. Thin ice is now in the area during winter times, but the ice may be thinner in future. And of course, when all the ice is disappearing from this ocean north in the North Pole area, then we will see around 9 million square kilometer territory of open. And of course, then we have new shipping routes, and that is going to be a reality. We only don't know when this is going to happen. And of course, when this will happen, infrastructure will be needed, harbors will be built, airfields, roads, power plants. And at the same time, we will have access to new resources. Take a look at the Greenland. The Greenland is an upcoming mining country, maybe one of the largest on Earth in future. And Canada is also rich on ore. And we will also see new fishing grounds. Sure. And during the Mosaic exhibition, they even managed to catch cod during the winter time under the ice. And that was something they didn't expect. And of course, due to all those activities we will see in the next, this century in the Arctic, we will of course see the population growth there. We have now within the Arctic Circle around 7 million people living, but that will change. That means those people, they will need food, they will need fuel, and they have to be able to travel. So there is a lot of movement, a new movement going to happen. Vessel owners and operators, they try normally to avoid situations like you can see here on this slide. Ice, drifting ice, or ice blocks of the size of islands, and those you cannot see on the radar. High waves and rough sea, high wind speeds, cold climate and low temperatures, fog, and all this can make your voyage more difficult. It is maybe more difficult to navigate through ice-free area in the cold north during wintertime with all the fog and also ice from time to time in the area instead of going through thin ice the whole route. It is quite tough. And investors, they like to avoid situations as you can see here on this slide. Limited lowland for building up airstrips, permafrost all over, steep and rocky mountains. You have maybe a very deep fjord, but no lowland. Remote areas and darkness all the day, all the night. Mosquitoes, all over mosquitoes. Poor level of education and social problems within the population of those smaller villages all over the Arctic. And of course, lack of infrastructure. So it's hard to start. All projects in the Arctic are more expensive than in the south part of the Atlantic. I will now bring you to our project site in Finnafjord in the northeast of Iceland. As you can see from the red circle, it is on the south side of the 45-kilometer long peninsula there. And that peninsula is protecting this fjord from north winds and waves. You can also see that we have glaciers in Iceland, by the way, the largest glacier in Europe. And the whole sea all around Iceland is all the year round ice-free. This photo was taken from a plane in the year of 2014. It is ice-free site all the year around and almost no snow on the lowland. We have been operating wind measurement stations there and weather stations since many years, and we see speeds in the shore area, and normally very clear wind directions, and the temperature is rather mild. It's rather mild climate there. The average temperature over the year is higher than the average temperature of Manhattan in New York City. So does it look like? It is without trees. It is no permafrost there. It is flat and dry landmass, easy to move, easy to construct. And it is even an ideal site for a full-size landing strip. And that is something we have been thinking about to implement in the project. And that is, of course, absolutely unique to have at the same spot deep sea port and airport, especially then for cars. The whole landmass is gravel. The gravel is pure. It is of different size, easy to use for construction, and the quality of the gravel can be used for concrete mix. The shore side is without rock. It is gravel, and the fjord is deep, and the sea is calm. And as you can see, it's very flat, and there is almost nobody there. Our view of the development in future is the following. We will see multi-purpose vessels be more in the northern part of the Atlantic and along the Northern Sea route than we have seen in the past. Those multi-purpose vessels, they will bring containers, of course, partly with other goods. This may change after 2035 or 2040 and be a whole year basis, but at least during the summertime, long summertime, that means 6 months, we could operate vessels with high ice class. But the focus during the next years to come will be on the bulk and the break bulk, we believe. And there are a lot of interesting opportunities there. The mining material from Canada or Greenland, all the cars, trucks, trains, timber products, power units, building material, and wind power plants, all this will come with vessels, be moved with vessels. And not forget, we will see new cargo come into the mix. That means ammonia and liquid hydrogen. Ammonia is the future of the for larger, and this is going to start soon, maybe 2026 or earlier maybe. And liquid hydrogen is also an option. And you should know that in the Arctic, we have a lot of renewable energy, and but that is far away from the consumers. But we could produce e-fuels like ammonia there and bring it to the markets. Therefore, a part of the stranded renewable energy in the Arctic will be discovered and utilized. If you take a look at the land, Greenland, with all the ice, you could say that the ice there is the largest battery on Earth, full of energy. And those rivers, all in each and every fjord, there are rivers bringing that liquid water to the sea without generating electricity now. And the wind potential is huge. For instance, in Iceland, close to the Finnafjord project, on the hills there, we have better utility rates onshore than you can see offshore in front of the coastline of Germany and Holland. But of course, the investment cost behind each megawatt hour is lower on land than on sea. And not forget, we will also see much more fish be transported from this area on the demanding markets. Then we are talking about fish from the seas. New ocean will show up, and we will also see more fish farming on land as well in the sea. And we are maybe talking about 5 to 8 million tons plus per year from 10 years from now. So the breakbulk is definitely going to be more than we see today, and of course with container under deck, because container goods, they have to be protected from the cold. And we will also see ore be transported in the area to the demanding markets. Also special carriers like this one on the left side down. You can see a huge yellow steel construction. It's a fish farming cave taken with a special vessel from COSCO to Norway some years ago. And then, of course, we will see more car carriers go along the northern sea route and the central sea route in future. So this is the Finnafjord south side as we see it. I'm not going to show you the north side, but this is the south side. It's a 5 kilometer long site. On the left, we have the search and rescue and service port. Then we have the mining material coming in smaller portions with smaller vessels from Greenland, maybe from Canada. And then that will be taken out in larger portions on special vessels, huge vessels to the demanding markets. And then in the middle, we have the container terminal, and in combination with the breakbulk terminal. And behind that, we have factories doing all kind of assembly on those bigger units, maybe wind power plants or whatever. Then on the right, land hydrogen and ammonia production on the far right side, and export terminal for liquid ammonia or liquid hydrogen. And this terminal is as well a fuel station for those vessels in future. So the Finnafjord is definitely on the beaten track. It's a hub port and a way port for trans-Arctic container and breakbulk shipping. And this route, the central polar route, is of course very interesting when it comes to the Finnafjord, because that will shorten the way quite a lot. And this is going to be a bulk port, industrial site processing mineral products from Greenland, storing up temporarily material. And this is an Arctic research and rescue port. And of course, site for harnessing 100% renewable energy to produce alternative fuels for the vessels of the future. And of course, as well, proteins for our human being. The PPP model structure is like that for the project. We have on the left side the municipalities, 2 municipalities. They are cooperating on this project, and they are running the Finnafjord Port Authority, the blue. And on the side, we have the landowners, private farmers, owners of the land. They are living in other areas, and they are renting that land to the concessionaires through the Port Authority. And then we onboard the Red Box as a Finnafjord Port Development Company, together with Bremen Ports, the fourth largest port in Europe, and some investors. We are preparing the project so concessions can be given. And now we are working on social impact study and framework plan and environmental impact assessment study. Basic design guidelines are in preparation for the concessionaires, depending on what kind of terminal they will operate. We do think that between 2022 and 2028, we will be able to tender out the hydrogen and green ammonia production terminal and land-based aquaculture related to that or connected to that territories, let's say. That is of interest because land-based fish farms need a lot of oxygen. And if you are producing hydrogen, you have a lot of oxygen as a byproduct. And then after 2028, we will see a multi-purpose terminal come in operation. And from 2030, the breakbulk terminal will be realized, and maybe earlier, but we say 2030. And we believe that the real container traffic will first start in the year of 2035, maybe even 2040. And after that, or similar to that, we will see the bulk terminal come up, because then Greenland will be a real mining country. A lot of things are going on in Greenland today in this direction. So here we can see those project partners we have on board, the two municipalities and the Bremen ports. Thank you so much. And don't hesitate to contact me if you have questions related to the project. Thank you.
Well, once again, it was Mr. Hafstein Helgesund from EFLA in Iceland under the topic of infrastructure development of plan for Arctic container shipping. Well, before we started, I paid a great attention in the beginning as well. Just to remind you, he told, the history told us to predict what kind of actions to be taken scientifically, it's better to actually make plans. So we need to keep in mind, we observed that in the situation of the COVID-19 pandemic, and to predict the infrastructure development in the Arctic region, I think the same methodology should be applied. So what's happening in the Arctic, just simply monitoring and to understand the change, it's not enough for us. We should feel by ourselves, on our skin, the changes. So, as the regular service operator, he shared with us their business, operation direction and the business philosophy. It was quite interesting. Next, he also explained the prospects of the Northern Sea route by year, and at the end of the presentation, and he also shared with us the business plans for the future. So, just to remind you, let me summarize it. If you look at the graphs, it will help you better understand from the city government. Finnafjord, the Port Authority is established, which is 100% owned by the local, government. So obviously that's what we are doing in Busan as well. That's traditional methodology to operate a port. So, and I think it's quite similar to the second point as well, to attract investors. And for the Port of Bremen and EFLA and other local governments, to encourage participation from these stakeholders to develop the port and to designate operator. I think that is the true, methodology to implement PPE. And last but not least, he also shared a roadmap to select the operator and development of the port infrastructure. Now we have all three presentations, and actually we are running about 10 minutes behind the schedule dedicated for the session. I believe that there can be some questions from the floor. I think there is a question it's directed to Mr. Belkin, Mian Belkin. Unfortunately, I do not see him connected online. Well, oh, I see Mr. Belkin at the bottom of the screen.
Hi, sir. Is it okay hearing me?
Well, there's a question directed to Mr. Belkin. I believe an interpretation will be provided. Okay. I think someone from the floor gave this question to Mr. Belkin in the Northern Sea route. It's quite interesting. I think the question is very interesting. In the navigation regulation in the NSR in the past, we believe it was divided into 7 sectors. But the revised navigation regulation in the NSR, according to the revised regulation, it's not 7 sections. It's more than 40 sectors. So when it was announced, I'm not sure, but anyhow, it was quite recently revised. So now we have more than 40 sections in the region. So that means the subsidies for icebreakers and support, etc., what kind of implications it will have. So the question is, the revised regulation, what kind of implication it will have?
Thank you for your question. I hope it's okay with the sound. Do you hear me? Well, I hope that's okay. Thank you very much. That's a good question. First of all, I would like to say that everything which was done recently to the regulations is done to provide a better detailed understanding of how to treat the conditions on the Northern Sea route. Let's say we did not change significantly. I mean, we, the Ministry of Transportation, Rosatom, and the government of Russian Federation, of course, because these new rules, they are adopted by the decree of the Russian Federation government. We did not change anything which concerns the process of application for the permission. In order not in any case to hamper the let's say the process of a client applying for the permission. So nothing was done to make it more difficult. Everything instead was done to make it easier for the clients, let's say for the user of the Northern Sea route, let's put it like this, to use Northern Sea route. The idea to divide into more sections, that's to make it easier to plan the navigation via the Northern Sea route, because you know, conditions on the NSR. The NSR is a very big, let's say, area. It's more than 2,000 nautical miles in length, and more than 200 nautical miles, let's say, in width. So the conditions on the NSR are quite different in different areas. And the bigger areas you have, the bigger division you have, the more difficult, the harder it is for you to take into consideration all minor zones where ice conditions may differ. But when you have smaller areas, it's easier to take into account the conditions of these particular areas. So because the ice conditions, the currents, the winds, the temperatures, they can be different in several areas which fall within larger zones. But if you divide them into smaller zones, it's easier to, let's say, it's easier for, first of all, for the customer to plan its voyage. And secondly, for us, for Rosatom, to provide icebreaking support and to provide routing for this vessel. And it's of course easier for the administration of the Northern Sea route to process the application and to issue permission. So in this case, everything is done in order to make it easier for the user of the Northern Sea route to plan its voyage.
Well, I hope the one who asked the question fully understand the question and answer. Okay, I think it's quite enough. Answer the question. All right, and do we have more questions from the floor to other speakers? Okay, we have, from various parts of the world, participants are connected online. It looks like we do not have further questions. Okay. Well, obviously, it's not difficult to say hello to everyone, but at least I'd like to once again extend my appreciation to the three speakers for this session, and we will conclude this session here. But okay. Yes. So joining the Arctic Shipping Seminar, I feel a lot of the things and have a lot of thoughts. But personally, what I see is that looking at the development of the Northern Sea route, maybe so far we had just really rosy fantasy pictures, because the full openness of the NSR, the significance or the meaning of it, I believe it is one of the most important agendas for the humankind today. And it is certainly based on the climate change. It's not just about climate change. It has really big implications on the daily life of all human population on Earth. So it's almost like watching in a fairy tale, like Cinderella. Is holding a kind of a really delicious looking apple on her hand. So this is how I feel about the Northern Sea route. Progress, but however, we have possibilities and also some challenges, but certainly that poses a great challenge for us, a lot of homework to do. So taking one step further, what are we going to select? What kind of options? Are we going to focus on commercial operation, or are we going to focus more on the potential environmental, destruction? Maybe someday we will just, be at the point where we have to make a choice between these two. But until then, I sincerely hope that we will put our heads together, come up with a really, wise and smart solutions for that. Well, do we have a question?
Hi, hello. Yes, I have a question that might be addressed. I was thinking more primarily to Mr. Fraser, but probably to all three speakers. And my question is related to the role of the local populations. You have mentioned in some of your presentations that, of course, it's very important to consider the rights of the indigenous peoples and First Nations. And I was wondering whether you could say a little bit more of the complexity of managing the development of the Arctic, and also the benefits of the developments in the Arctic for the local population. That's very relevant, of course, for Iceland and for Russia as well. But I know this is a very important topic for Canada.
Sure, may I proceed? Can you hear me? Thanks for the question. It's a multi-headed one. I'll do my best to answer it concisely. At the end of the day, the regulation of shipping in Canada is vested in a federal responsibility. But in recognition, as I alluded to in my presentation, of the rights of Inuit within Canada's 3 territories and in the northern parts of a handful of Canadian provinces, the government of Canada is quite invested in this concept of co-management. So that is to involve Inuit in particular in the decision-making process with respect to where shipping should occur, to determine ways in which the potential negative impacts from shipping can be addressed. Right now, as an example, there's a process underway in the eastern approaches to the Northwest Passage to define what's called a national marine conservation area. And this is being done hand in glove with the Inuit to respect their traditional livelihoods. The water and the sea ice is essential for food security. And there's the potential that shipping can interrupt the ability for local populations to meet those food security demands. So I think this would likely require a whole presentation unto itself. It is a complex topic. There are a multitude of legal issues, of social issues. Canada is unique in that its Arctic is not connected to the south by road networks. Everything is either flown in or shipped in. So shipping does kind of take on a whole new identity, if you will. You know, in as much as Canada is trying to develop ways and to sort of further a relationship with locals in the north, it's far from a perfect relationship. So I think that there's certainly work to be done, though I believe, and I'm selfish in saying this, that we are sort of embarking upon the right path forward. Maybe I'll stop there. I know you had a couple other perhaps related questions, but I will afford the opportunity to other panelists to respond if they feel so.
Thank you. Hafstein Helgason here in Iceland. I could maybe give a short answer to this. Here in Iceland, we are not dealing with the same problems as you are dealing with in Canada. Regarding the project I mentioned, the government of Iceland is supporting that project. Also those two municipalities involved, and all the land along the coastline of Iceland is owned by private people. Only the highland in the center of the country is, so to say, owned by the state. And those owners of the land, they are very pleased to be involved in the project. And you should have in mind that on both sides of the fjord, we have two small fishing villages. And all jobs there, they are quite monotone. Let's say there is a need for new kind of jobs in the area. So a lot of young people, they do not come back to their home after getting education in the south, in the capital. So they are very much pleased to see new opportunities come up with this project. But at the same time, we, as well as the municipalities and the government of Iceland, we are very much concerned about the environmental part of the project. And therefore, we have set up, so to say, rules that each and every vessel must be connected to the electrical grid of Iceland when it is in the port. And we do hope when the port will be, let's say, up and running, then we will see alternative fuels, as I mentioned, as fuel for the vessels. So the project will be indeed very much of interest for the vessel operators, because there they could get fuel on very attractive prices. Thank you.
Well, so far, we have exchanged, comments and questions amongst, the speakers as well. So in Iceland, well, I think it's early in the morning, but in Canada, I believe it's really late at night. And we are having, participants all over the world once again making this seminar really international, gatherings. So now we are running about 20 minutes behind schedule. So we will conclude the session 2 here. Once again, thank you very much for your participation and time. Okay, with this we will conclude session 2, and session 3 will begin at 5:05 Korean time, and we will try our best to wrap up the entire seminar 6 sharp. Thank you very much.
New roads of delivery. Unico Logistics. Unico Logistics, as a global comprehensive logistics company of possessing 43 overseas LLCs and branches with powerful global network, provides ocean freight, railroad transportation, heavy logistics projects, and air freight service, and also provides warehouses, customs clearance, delivery, and intercontinental truck transportation services. Unico, as a global player, is transporting freights from all over the world to the optimum routes depending on the size and type of the cargo. Freights of various industries such as construction, engineering, electronics, chemicals, and automobiles are shipped to the customer's designated destinations through our worldwide network in the most reliable and fastest way. Unico is in the transport of project freights anywhere in the world. With our infrastructures in global networks, and with our live controlling system and experiences, we've been able to succeed bulk shipment projects for fuel, gas, chemical, and power plants of global construction companies. Which means our project freight transportation capability is provided to meet the client's needs. That's why Unico can be found at any heavy engineering project sites. Unico's know-how and network continues to develop in the air. By affiliating with all the major airlines in the world, we provide the best service through years of shipping experience. In addition, warehouses and trucking services are prepared at any time and anywhere in our overseas locations around the world for the customer's convenience and needs. Also, as we possess our own dry bulk carriers, we've made shipments of imported raw materials used in domestic and overseas power plants and steelworks, such as coal and grain, which we achieved an increase of 30% or more in cargo fulfillment rate every year. With these achievements, we will continue to serve as an industrial carrier by increasing our fleet. Our efforts for the future will continue until Unico's logistics and shipping are established in major cities around the world and become a truly global player. Our voyage will continue. Unico Logistics.
Now we will resume the seminar for the session 3. And for the third session, we have 2 presentations ready. And as a moderator, we have Professor Hee Sung-yoon from Korea Maritime and Ocean University. Please welcome him with a warm round of applause. Yes, finally, we are at almost the end of the seminar, the session 3. The topic is future cargo transport via Northern Sea route. I believe we will have a lot of insights from the presentations ready. We have 15 minutes dedicated for the session, so I believe we have 2 presentations, 20 minutes each. Then we will have a quick Q&A. And we now start at 5:05, and I hope we can wrap up by 5:55. So in the session 3, we will address more specific issues. So the first presentation is about shipping cars across the Arctic, the potential for pure car carriers using the Northern Sea route. That will be presented by Professor Michael Acciaro from the Kuehne Logistics University, Germany. And the second presentation will be delivered by Mr. Dong Lee from Unico Logistics Korea under the topic of what is optimal cargo for TSR and NSR. Okay, then let me invite the first speaker, Kuehne Logistics University, Professor Michael Acciaro. Please, Professor.
Hello, my
name is Michele Acciaro. I'm the director of the Hapag-Lloyd Center for Shipping and Global Logistics and associate professor for maritime logistics at the Kuhn Logistics University in Hamburg. I would like to thank the Institute for Arctic Logistics of Yongsan University for the kind invitation to speak at the 9th International Arctic Shipping Seminar. Of course, I would like also to thank the host, the Korean Ministry for Oceans and Fisheries, and the Busan Port Authority as a sponsor of the event. It would have been a great pleasure to come to Korea and to Busan in particular, where I have never been. But of course, we'll have to wait for better times when we will be able again to travel internationally. I would like in particular to thank Professor Sung-Won Hong for the suggestion to prepare a presentation on pure carriers and Arctic shipping, as this is an area that I was really interested in exploring. A large part of my background is in container shipping, and of course looking at pure car carriers requires having a different view on this sector. So thanks a lot for this opportunity, and I'm looking forward to hearing also of the rest of the symposium and the other participants, what are the current developments when it comes down to logistics through the Arctic. Obviously, cars are an important product being traded between North and East Asia and Europe. The European car manufacturers estimated in 2019 that Europe exported about 500,000 motor vehicles to China, and half of that to Japan, and 175,000 to South Korea. And Europeans also imported 762,000 vehicles from Japan, about 500,000 from South Korea, and an increasing market also from China with 250,000 motor vehicles. This results, according to a study published in 2015, to about 1 million tons of potential car trade between Northern East Asia and Europe. The great advantage of this trade is, of course, linked to the shorter distance. If we look, for example, moving cargo from Yokohama to Europe would result, if the Northern Sea route was used, in a reduction of 40% with respect to the Suez Canal. And similar benefits are obtainable also from other ports globally. These are, of course, reflected not only in the distance, but also in a substantial reduction in transit times, where we would have a difference of several days when the Northern Sea route was being used. The business case for the Northern Sea route is quite clear. If you look in the map on the right, which has been developed in a study published by ECORES that was carried out for the European Commission in 2019 and that was presented at the Hamburg Symposium on Arctic Shipping last June 2019 of last year, we see that the 35% reduction in route length also results in a substantial reduction in fuel. Now, the ECRI study was focusing on container, so we had to adapt some of those figures to the pure car carriers. And to do this, I use a study that was published in 2016, which used as a reference a vessel built in 2018 with a capacity of 6,500 car equivalent unit and a design speed of 20 knots. Obviously, it would not be possible for such a vessel to sail at full speed, so we would have to reduce the speed to 15 knots. In some cases, some argue that 16 knots would also be reasonable for the Arctic, but we will use two alternatives throughout this presentation, 16 knots and 18 knots. They result for one single voyage into a fuel consumption of 652 tons of fuel, or 838 if the vessel goes a little bit faster. That compares with the Southern Sea route through the Suez Canal and of course the Malacca Strait with similar speeds to instead 998 tons of fuel and 1,279 tons, which is actually quite substantial. This, of course, also needs to be compared to the price. We are at the moment relatively low price, so I've taken a very low sulfur fuel oil price average, global average of 377 US dollars per ton. This is, of course, an average which is a little higher of what would be the bunkering prices in Rotterdam or, for example, in Singapore. But considering the fuel prices are very low and have been very low in the last few years, this could be a good approximation. Now, this would generate savings. So moving from the Southern Sea route to the Northern Sea route would generate savings, depending on the speed, between 129,000 US dollars per voyage up to 166,000 US dollars per voyage. Of course, would be reflected in a car equivalent unit, in a saving per car equivalent unit between $19.8 and $25.5. Now, this, of course, would seems to indicate that the Northern Sea route is a clear winner, as the savings are really substantial. In reality, things are a little bit more complex because navigation through the Arctic is very dangerous and difficult. And for all liner trades, including car trades, reliability is a very important parameter. And because of the inability of sailing on a regular schedule all year round, and as well as the potential risks associated with weather, but also environmental and safety risks, we have to consider that the reliability of this route is much more limited. On top of this, of course, we have also a very complex geopolitical situation and a lot of uncertain economic benefits. These benefits are related to the logistics. The logistics is generally not a point-to-point, although, of course, for car carriers, we can consider as relevant movements from one port to the other. But of course, we would have to consider what the consequence for the logistics chain would be. And we also have to consider various constraints in terms of navigability. For example, the depth. The Lepta Straits is notoriously very shallow, and there are other points in the Northern Sea route which are relatively shallow. On top of that, we also have to consider the weather conditions. If it's true that on the one side, climate change has allowed us to have more availability of the Northern Sea route, or to have the Northern Sea route navigable for a longer period of time and for a longer summer, it is also true that climate change has also been causing much more extreme weather events that for car carriers are very, very important. And on top of that, we also have to consider the lower fuel prices and the excess capacity that make, of course, risky investments much less attractive. Also considering that in order to sail through the Arctic, we will need to develop ships with at least some ice conditions to be able to extend the navigability for a longer period of time, and in order to avoid risks of accidents. Now, let's have a look at a more realistic calculation, starting with capital cost. And in order to do this, I take an example of a MV Taurus Leader. This is a ship which has been bought and built in 2015. It's bought by, or is owned by Singapore Shipping Corporation, and has been chartered on a long-term charter to NYK. The reported purchase price from the press was about 80 million. That was reported in 2014, and the estimated charter price was 10.8 million for 15 years. Obviously, this is not an ice-class vessel, so we have to consider that if the vessel was to be transformed or had been from its construction an ice-class vessel, we would have an increase in the cost of the vessel. That would be 10 to 40%. So that would result, assuming a conservative 25% cost increase for simplicity, in about 100 million. We would also, of course, have to consider that the owner would expect to also have a similar premium on the charter price, and that would be, of course, if we consider a 25% an increase, that will come to 13.5 million charter price per year. Of course, these are assumptions, but I think they could be considered relatively realistic. Now, what would happen once we have the cost per year? We need also to evaluate how many trips could a vessel do throughout the year, and how many trips more we would be able to do through the Northern Sea route. In order to do this, we need to calculate what would be the transit time. You can see on the left-hand side, we calculated that for different speeds. Obviously, if we go faster, we have shorter transit time. If we go slower with 15 knots, we have longer transit time. And that results in the Northern Sea Route a case between 17 days and 20.5 days, while in the case of a navigation through the Suez Canal, that would result in 26 days or 31 days. We also have to consider that the vessel cannot operate 365 days. I'm taking aside in this case maintenance and accidents and any sort of type of disruptions to keep the calculation simple. We also need to consider the loading and unloading that is in these vessels is important, and it's very time consuming. And I use for this the estimation provided by Zhang in a paper published in 2013, a reference to all this literature at the end of the presentation that will be made available to the participants in the seminar. Would result approximately in 27 seconds per car. That means for a ship like the Taurus Leader, that would result, which carries 7,070 car equivalent unit, that would result approximately in 53 hours. And then we can consider 3 days just to round out berthing and getting inside the port, etc. So that will give us, in terms of transit time, would allow us to calculate the total number of trips that these vessels could do throughout the year. In the case of the Northern Sea Route, this would be between 18.25 and 15.5 trips per year. In the case of the Southern Sea Route, so through Suez, that would be between 12.5 and 10.7. These are again approximation. We would have to consider the availability of icebreakers in the Northern Sea Route and the ability to transit through the Suez Canal. But again, these are rough estimation to get a rough calculations. Also, very important, we have to consider that these trips are one way. So it would be necessary to find enough cargo on both ways. But especially from these routes, from the statistics that I've indicated, this seems to be a relatively balanced route. Although obviously there are more cars being imported to Europe than being exported from Europe. And so that would also be taken into consideration for a real cost-benefit analysis. Now, assuming the maximum possible loading, we can come, and assuming, of course, that each trip is being carried out with a full load, this will come, depending on the speed, to a transportation of just above 100,000 car equivalent unit, between 109,000 to be precise, and 129,000 for the Northern Sea Route, and instead a much more modest 75,000 up to 88,000 for the Suez Canal. Of course, we have to consider that the Northern Sea Route is generally not accessible all year round, so we will have to consider different scenarios. I followed here a tradition in a lot of those papers and developed and suggested 3 different scenarios. You see here a calculation of the output for the scenario where we have accessibility for 12 months, accessibility for 6 months, and accessibility for 4 months. And in the table, you can see the calculations that are a weighted average of the availability of the routes, which would result, in the case of a 15-knot ship, into something that ranges between, in terms of output, of 109 car equivalent unit, in the case in which the Northern Sea Route is used a full-time, full year, down to 86,000, almost 87,000 car equivalent units if we were sailing only for 4 months. And at the same time, we have, of course, in the case of a faster speed, 18 knots, that we would be ranging between 129,000 car equivalent unit down to about 100,000. So as you can see, the output is could be quite substantial, even in a system where we are not able to use the Northern Sea Route full time. Of course, not using the Northern Sea Route all year round implies that we have an increasing cost in the vessel, because of course the vessels that we would be operating is an ice class vessels that obviously would have also in principle not only higher capital cost, but also higher fuel consumptions. I have not considered the differences in terms of fuel consumption in this case, but even without doing that, that might be a small difference, and of course that will also require to consider the changes in terms of fuel prices. That gives, in principle, an advantage. These are the calculations that I've done for the three scenarios, and on the right-hand side, on the column on the right-hand side, the route through Suez. You see here in the first row the differences in terms of the cost of the ship, which is of course lower. This is of course the chartering cost, and you also see the difference in fuel consumption, and we can also see here the difference cost in total fuel consumed. So you can see that obviously the Northern Sea route will result in a lower fuel consumption, primarily as a result of the lower distance, so the 35% lower distance. We also have differences in terms of crew. I have tried to apportion those depending on the time in which the crew is sailing through the Northern Sea route, assuming that more crew is necessary in the case of the Northern Sea route. And I use for this the same assumption that Lasserre has used in the 2016 study. And we have, of course, differences in insurance and maintenance, although they are not that substantial. Very critical in these analyses are also the transit fee that are charged by Russian authorities, primarily for the use of icebreakers, and the use of icebreaker is compulsory. And you see that these figures are very substantial, and they tend to decrease as we use less the Northern Sea route. They are proportional to the number of transits. Of course, we also have costs associated with the Suez Canal. These are numbered by transit, and I apportion them also depending on how much, of course, the vessel is sailing through the Suez and through the Northern Sea route. And then, of course, we have the difference in output that were calculated before. And you can see that in the case of a full use of a Northern Sea route, we have actually an advantage of, with respect to a Suez Canal, of about 7%. And in the case of a higher speed, of almost 10%. This advantage, though, is lost quite rapidly because in case we are not able to use the ice-class vessel all year around. And you could see, though, that with these figures, we are almost have similar advantages with compared to the Suez Canal. But of course, that does not compensate for the very much higher risk that we have associated with the Northern Sea route. So if you see in this summary, I put here a picture of a Russian icebreaker that is necessary for the sailing. And we can see that the reductions we have are in the range of a 1 digit and actually probably much more modest. And of course, we could argue that since the icebreaker fees are one of the major drivers, and it is likely that these fees are negotiable, I use in this case the same assumption used by Lasserre of $38. They're actually 1,048 ruble per ton of cargo. And I've also assumed in this case that the Russian authorities would actually charge the cars by weight, assuming a weight per car of 1.6 tons per car equivalent unit. Of course, it would also be possible that the Russian authorities would charge a ship by deadweight ton, so the carrying capacity, in which case we would actually have a 4 times higher cost. In this case, of course, we would have to have a much more substantial reduction in the fees per ton to actually make this a valid option. Now, the current state of the pure car carrier segments is not very encouraging. So if you see, these are the development of the pure car carriers, we see that the fleet has not been growing very fast, and actually a large portion of the fleet has been demolished, as it can be shown by these diagrams here, indicating that the segments is not very healthy at the moment. So we have observed very low freight rates, and although the industry has really tried to rationalize, still, there is a lot of risk that make an investment, especially a risky investment, such as in a ICE class car carrier, very unlikely. We have, of course, geopolitical and trade tensions, we have social unrest, we have recurring climate-related natural disasters, and of course, a lot of risk associated with the COVID-19 crisis. So the business in this case is very conservative, and we have seen that the only new vessels that have been built were those that were associated or backed with car manufacturers, such as the NYK purchase last year of 2 car carriers, new car carriers backed by by Toyota. But this has also resulted in cancellation. Last year we had a CM Ashanti cancellation where the vessel was almost completed. The sailing conditions in the Arctic are extreme. Vessel needs to be adapted to these conditions. And of course, this depends on the typology of ice. We have, of course, young ice, but we also have old ice and ice ridges that make sailing very difficult. We have very complex navigation and SOLAS and MARPOL. And of course, we also have country-specific regulation. And on top of this, we also have, of course, an enormous amount of risks which are associated with accident, the geography, but also the environment and stakeholders. So the current business case does not really seem to compensate for the very high risks associated with sailing through the Arctic. Through some email exchanges that I had with industries, I asked Wallenius Wilhelmsen, and they replied to me in the email that in view of the current and foreseeable commercial, technical, sustainability and operational considerations, Wallenius Wilhelmsen does not envisage the Northern Sea Route or Northwest Passage becoming viable for them. And so they do not see this as an opportunity. Other players I've spoken to, though, do see this as an opportunity. I've also spoken to the Port of Bremen, and for them, the risks of developing Arctic shipping, and they, especially in terms of investment, and they are active in Iceland with the Finnafjordur project, which originally was also, of course, associated with having connections through the Northern Sea Route, and Bremen is, of course, a very important car port. They also specified that for them, the environmental risks are too high. And even in their business plan for the Finnafjordur, they have tried to focus more on the local population and on green energy. So what is the future for the Arctic? I put here a picture, of course, of a gas carrier, because, of course, I think the Arctic has a much better business case for raw material extraction, as been already observed, but maybe also the growth in traffic driven by local development, mining, but also the development of local communities, which is a strong priority for Russia. Maybe also tourism and the occasional transit traffic. While for container, we might consider to have hub and spoke linkages, maybe taking advantage of maybe ice class or even navigation throughout the year in the Arctic with ice resistant, maybe class vessels. And although there is a lot of uncertainty here or where the hubs would be, whether it would be in North Scandinavia or maybe in the Sea of Okhotsk or in the Bering Sea, we do not have this possibility for pure car and truck carriers. So the outlook for this industry, in my view, remains relatively limited unless we have car manufacturers that are really willing to foot the bill of building these larger vessels and also taking the risk. And considering the relatively high reliability of moving cargo through Suez and the relatively low volume that are being transported, or at least the forecast for the relatively low volumes, I don't think that this will be happening in the near future. So I would like to thank you for this opportunity. I've put here the references to the presentation, and please feel free to contact me if you have any questions, and I'm looking forward to questions from the audience or further discussions.
Thank you very much for your, Professor Acharya, thank you very much for your presentation. I thought about wrapping up your presentation or summarizing your presentation, but due to time constraints, let us move right on to the presentation to be delivered by Tom Lee of Unique Logistics, and I will save some time for Q&A session. Good afternoon, ladies and gentlemen. I'm Tom Lee of Unique Logistics. I'd like to go back to the previous slide. This is the agenda for my presentation. I will first start with the background of this presentation or this study. Then I would like to move on to the current EPC project in Russia, as well as some CIS project as a case study. And after that, I will briefly touch upon the competitiveness of the NSR. And I will also supplement that with some other case study with the example of the Ust-Luga project. And then I will conclude my presentation with some thoughts on how to improve the use of NSR. As I prepared this presentation material, I searched for some news articles with the economic crisis triggered by the COVID-19. And despite this situation, the navigation via NSR has gone up in terms of the number of vessels, as well as the cargo volume. However, if you take a look at the dry cargo, the overall volume has gone down. Not just the MSC, Hapag-Lloyd, and Maersk, as well as other container carriers, are quite skeptical about the Northern Sea route. Well, I think some environmental factors have been in play in such a decision not to use the NSR. And with that in mind, what about the liquid cargo and dry cargo? What kind of dry cargo we can handle? I think EPC project cargo would be the most suitable cargo for the NSR. And although we do not have time to go through each and every detail, there is quite a number of projects going on in CIS area as well as Russia. It takes some time to move on to the next slide. And this is the first case study I'd like to share with you. And this is the case of Kazakhstan. It is located in the Central Asia. There are two potential routes here, and one is via Suez Canal and doing the inland transportation after that, or starting from Tallinn and using the river canal and going through the Caspian Sea. And this is the most typical route. But given the location of the Kazakhstan, I think we can make the most of the NSR to have the shortest possible route. And that's the route we have identified and actually used for this project. And you can refer to the photos on the slide. We load the cargo on the crane. And if it's in the square form, then you can just load it, as you can see. But if it's in a circled shape, then you'd have to use this kind of a standing structure. And you would have to use a trailer custom made for this kind of cargo. So this is how we shipped and transported this shape in circle-shaped and round-shaped cargo. And here, to compare the NSR and the traditional route, the transit time would be about 1 month shorter if you use NSR, and you can save some cost and the fixed cost, especially. Then it is easier for you to secure any vessels or equipment if you use the NSR. And offshore or onshore transportation is easier. And because you would go through a fewer number of borders, you can save some civil work. And to turn to some weaknesses, the first is that although there is a great number of plans, a navigational period is relatively short. It's available only in the summer, and because it's available only in the summer, there is a possibility of congestion in landing or arranging an icebreaker. So the availability of icebreakers can pose some potential risks as well. And as you can see on the right side of this slide, if you go inside of the country, then you can create this kind of anchorage in a relatively easy way, minimizing the environmental impact. So you can do this kind of a waterborne transportation closest possible to the destination to minimize any kind of environmental impact. So this is another project case in Ust-Luga, which is quite close to St. Petersburg. Its location is quite interesting. First, you go through the NSR, and as for the oversized bulk cargo, you can use the NSR. And as you do the project, you might have some urgent need for delivery. In this case, well, you can use TSR. And as for a planned dry cargo, you can use a container carrier to go through a Suez Canal. So 3 different routes are available to the site. And we identified the need for coordination. So we came up with an idea of a forwarding company. I'm not here to promote my company or do some advertising for this company, but this is a company that encompasses all different types of transportation. Well, as a one-point contact or the contact point for all these modes of transportation, then we can do the coordination. Not just that, we get an investment from the DP World, and so this is the company which actually sponsors one of the most famous golf tournaments, where our Korean player is playing and expected to win. And this deal has been almost completed, and by next year, we will see a complete integration between the 2 companies. And another aspect I'd like to highlight is that DP World has agreed to jointly implement a project for integrated development of the NSR in partnership with the Russian Direct Investment Fund, as well as the Rosatom and Norilsk Nickel. So based on all these facts, in developing the Northern Sea route, with whom should you form partnership? I think, well, forwarding company can serve as an enabler, because it is a project specialist. In addition to that, we have an ocean specialist, and it has the capability to run the TSR as the one contact point or coordinator. Forwarding company can be a great enabler. So if we can fully utilize a forwarding company, that would be the most effective and efficient way, which puts together the environment, logistics, and all different factors to ensure success. And the process would require a significant level of negotiation and collaboration and coordination. And the cooperation is the key among the stakeholders. If we can do all this, then we will be able to create some win-win solution for everyone involved with regard to the NSR. A lot of topics have been covered and addressed, and I'm the last speaker, and due to time constraint, I try to be very brief and to the point. I'm very glad that I can finish my presentation on time. Thank you very much.
Well, once again, thank you very much, Mr. Lee, for your presentation. In the first presentation, Professor Achero talked about pure car carrier, potential of operation of pure car carriers in the Northern Sea route. He also shared with us some data and comparison and analysis on the capex and operational related costs, and to come up with, the outlook on economic feasibility. So he also shared with the conclusion, yes, it's quite complex, the current situation we have. There are many risks involved and uncertainties, including environmental concerns. Yet, still there is the possibility of a growth in certain aspects. And the second presentation talked about the Project Cargo. So the key point here is that because it's based on multimodal, as a logistics integrator for forwarders, there will be a big role to be played. So that is the significance of Project Cargo. Okay, now we have some time left for questions and answers from the floor. If you have questions, please raise your hand. And here, if you, as shown on the screen, we have, the participants connected online. Also, if you have questions, please raise your hand so that I can take questions. It doesn't really matter, questions, comments. It can be either to one of the speakers or to the participants. Please feel free to, ask questions. Well, it doesn't have to be, only limited to this session. Throughout the seminar, if you have any, issues you'd like to clarify, comment on, so we have some time left. So this is a really valuable moment for you, for all of us to share really insightful, ideas amongst us.
Hello. Do you hear me? Thank you. Good morning from Norway and good evening in Korea. I have a question to this session panelists, but probably also to speakers from other sessions. When you speak about environmental considerations and concerns, what basically you mean? Because according to understanding of our institute, I hear myself. Yeah. Should I repeat what I told? Okay, sorry. So I would like that speakers elaborate a little bit on environmental concerns and considerations. Because if we compare, according to our knowledge of the institute what is doing environmental studies in the Arctic, we have more questions about Arctic environment comparing to southern seas than answers. But then suddenly everybody talks about problems, kind of doing a parallels with the southern regions, while we do not. So could you define when you say about environmental concerns, what is basically meant? Thank you.
So your question is about environmental concerns and considerations. So is there anyone who can address this question among the speakers? So if there is anyone who can address this question, please proceed.
Thank you. I'd like to relate, of course, and confirm what you are saying. There is a lot of unknowns, and unknown imposes from a business perspective a very big risk. So obviously you don't have the same type of support that you might have in other regions of the world in case, for example, of an oil spill or in case of an emergency. The situations are more dramatic, and therefore these can impose risks which are higher. Of course, I agree with you when these solutions could be improved over time, but they impose a very, very high risk on the operators. And the two I spoke to, but I understood from the chats we have on the panel that maybe Asian operators might have a different view. But with the CM operators that I spoke to and Wallenius Wilhelmsen that I spoke to, for them, these uncertainties are a no-go, because the last thing that they want to do is, of course, run any risk. So even if potentially the risk could be controlled better, the fact that the unknowns are there and the very harsh environment imposes us to be very cautious. And also we have to consider that the Arctic, many areas of the Arctic are very vulnerable ecosystems, they are very pristine ecosystem. So as we have experienced in other examples, the most known of which is the Exxon Valdez, when we have any accidents, and the Exxon Valdez was a relatively small oil spill, but if we have any accident in these areas, they attract an enormous attention from the side of the media. And I think for car carriers, I can speak, but I think also for container operators, this would impose an enormous reputational risk. And that's the reasons for which this environmental risk can be considered, even if unknown, much more relevant than what they would be in other regions.
Thank you very much. Okay, to Mr. Belkin, if you are still connected, because you are from the Russian, regulatory authorities, so I'd like to hear from.
Yes, I'm here, but I would like to just revise the question. The question was about the environmental issues while it's developing Arctic, if I'm not mistaken.
Yeah, I can specify especially for you, Mikhail, possible. Because it was, as Michel mentioned, more concerned about uncertainties. When we do not know from one side what environmental is and what are environmental problems, and from another side, how these problems can be fixed, then it creates wide uncertainty that business cannot take. And you are the one who is actually closing the gap on the side of response. So it would be very nice to hear your comment, how well you are prepared in case something happens.
Thank you very much for your question. I think ecology is the critical issue when you are doing any kind of development, especially industrial development. In our case, I would like to say that we are well prepared for, let's say, hope nothing will happen, but for potential technological disaster. But in any case, there is a big, let's say, big road ahead, because we see that currently the shipping on the NSA, and I'm going to speak only about shipping, if you don't mind, because this is my sphere of responsibility and expertise. I'm not talking about land-based facilities. When we are talking about shipping, currently we have a big, let's say, development, big increase in shipping that almost like a big bang. Less than, let's say, 5 years ago, we had 7 times less cargo flow for the NSA than compared to what we're having now. And as I mentioned in my report, even the strategy of development of Arctic zone of Russian Federation says explicitly that the development, the economic development of the NSA is ahead of the infrastructural development, which we've got to close very fast because the cargo flow, the traffic through the NSA, and of course the number of vessels, big vessels which are going through the NSA, will be just increasing more and more. What I can say is that, again, all the legislation which I mentioned, especially the new rules of navigation through the NSA, they are meant to avoid any issues which can lead to disasters. Those are the rules which define what vessels can be used to navigate NSA, what ice class is required, and what support you need from the state-owned enterprise. Like, for example, in our case, icebreaking support. Then
again, in my report, there was a table which showed the development of ice-breaking fleet, which is especially needed to provide which is needed to provide ice-breaking support in the very first place and to let the vessels proceed through the ice-infested waters without any problems and without the danger by ice, and thus control damage. Now we have a full-scale fleet of emergency response vessels under construction by the Ministry of Coastal Affairs. There are about 16 vessels which must be built by the year 2024. And they are specialized vessels for the Arctic navigation. Some of them are icebreakers, like Megalith. They're not atomic, they're conventional vessels. But they are specially equipped to combat potential oil spills and to provide search and rescue operations for vessels in danger. So I would say that currently the state takes quite profound measures to make NSC safe and sound, and to be able to provide response to any potential dangerous situation or any emergency. So if this answers your question, this is all. If not, then we'll answer further.
Yes, good. Thank you very much.
Excuse me, and I'm sorry, I could not hear the English translation. So could you return again? Chairman?
You will make some comments on car carrier transportation. So now the floor is yours.
Okay, thank you. Well, thank you very much for very, very interesting presentation for all the panelists. And I was very interested in the pure car carrier idea scenarios. So, and maybe before the container transport, car carrier transport could be the one of the interesting and potential scenario to utilize the northern Syria. However, the environmental issues is really, really important. And the heavy fuel oil ban is going to start 2024 if the IMO proposal is adopted. So anyway, the shipping sector who try to use the northern sea route must be considered about the more seriously to use fuels and also other environmental protection issues. Thank you very much.
Thank you very much. I'd like to thank all the speakers and the panelists for session 3. And this concludes session 3. Then I'd like to hand the microphone over to the MC of the whole program. Thank you very much for your avid participation. I'd like to thank Professor Yoon for moderating this session. This concludes the 9th International Arctic Shipping Seminar. Before we close, I'd like to make some comments. I'd like to ask for your understanding for the poor connection, internet connection this morning and the poor quality of the video, although it was not aired and streamed via YouTube, everything is recorded on the Zoom platform. So if you visit the YouTube channel of Arctic Shipping Institute of Arctic Shipping and Logistics, and then you can take a look at the video recorded. And I'd like to show you the website of this seminar. All the presentation materials will be uploaded on our seminar's official website. I'm sorry it takes some time. So all the presentation files will be uploaded on the website. So all of those who join us virtually can pay a visit to our seminar website to get the presentation files. And by 6 o'clock, if you send an email to our research center's website, then you will get the full color booklet of the presentation materials via email. It's because it's full color, it will be much easier for you to understand all the materials and the content. So once again, thank you very much for staying with us till the end of the 9th International Arctic Shipping Seminar. Thank you for staying with us. Thank you very much.